But then, isn't it
these
easy just to bloody phone them?
these peanuts. I had no idea the conversations we get into before we start. Hey, peanuts. They hear us
Well,
talking
they
about
should.
something as we go live, and they go, "What are they talking about over there?"
It's because they're not in the gang, you see.
Oh, they're not in the gang. Yeah, they miss out on
No,
the good stuff.
that's right. So anyway, that's the secret to eternal youth and endless supplies of money. Let's get on with the show.
Oh, basically 42 then.
Yep, 42.
Yeah, and somehow
The
Farms
answer's
has got a
beyond.
secret access to my my YouTube.
Yeah, crikey, mate.
Look, it's not my fault you were 5 minutes behind.
I don't know, just YouTube just didn't want to give me my link to my own stream.
No, don't worry,
Yeah.
I'm already in it. I've given it a
Uh,
thumbs up and left a message.
I, I see a roll of it. I see a roll of Itzal toilet paper on the screen.
God, blimey, that's gonna make a clang.
and there you go. There's a pocket knife that everyone should have.
It's the YouTube artificial intelligence, Terry. It knows you're going to be late anyway, so it thinks.
Yeah, but Farmer. Why did Farmer get it first then?
Oh, dear.
So somewhere in there is a special tool for getting scouts out of horses' hooves.
Must be.
Must be. Not sure which one it is though. Live, there's everything in there. There's
Okay, post
There's
in the
two
chat
sets of pliers.
what tool you can see in that knife, in that Swiss Army knife. Well, I wouldn't call it a Swiss Army knife. I call it a Swiss Army something. Give it a name. Carl says I have one of
Brick.
those. Oh, yeah, sure you do,
That's,
Carl.
that's a Swiss Army brick, isn't it?
I,
Blimey.
I believe they actually did build something like that at one point as a as a thingy to have at trade shows
What tool you can see in that
with
knife?
every
Oh,
Yeah.
option.
am I coming through somewhere? Swiss Army knife. I call it a Swiss Army something. Give it a name. No, it's not me this time. Hey,
It's not me.
it's not me this time.
Mate.
It's a flat Earth repair kit.
Oh,
Ah, Bluey.
Oh, it's blue. Sneaking in the back. Sneaking in the back. What are you doing? What are you doing out in the back room?
I'm
I've
looking for the
actually
door.
just
I'll find it in a minute.
Oh, okay.
Uh,
He'll turn the
I
light
just
on.
found a link. I found a link to that Swiss Army penknife that you're showing.
Right.
Just over £7,000.
Whoa.
Has over 87 different tools. What's this website on? It's on a website called This Is Why I'm Broke. £7,006.58.
Does it have a sextant?
It looks like it's got a compass. Hang on, let's see.
you know those big plastic ones that have the blades open and close that you see on displays in shops and stuff.
Yeah. Oh yes.
When my friend downsized his shop, I think he sold that for nearly £1,000.
Blimey.
Well, he put it on eBay.
It's a Wybanger multi-purpose excuse knife. Hasn't got enough tools in it, stinks you.
That's the only thing I could.
A little wolf posted, we can hardly understand the conversations you have on stream. Like probably anyway or something as an end to that statement. Okay then. I see Alan. Sorry, I was just reading RT96. I see Alan's next.
RT96 needs his spanner taken away for that one so I can time him out.
Okay,
Yeah.
I'll do that.
Yeah, get on me, mate.
Take his spanner away. Okay. Yeah, removed. There you go, Alan. Have at it.
There we go.
She'll be right, mate.
Yeah, but I've got to give it back to them. That way
Yeah,
they
you
went.
can get-
That way they're not naked when they come back.
Yeah, because we can't be doing with that.
Oh, it's the weird accents that confuse Carl. What? You're
Oh,
accent
Carl?
farmer? You haven't got an accent?
Oh, I know.
No.
I ain't got no accent.
Yeah, Tommy Bastard.
My old booty.
Yeah.
The farmer with
Me,
his tractor. That one off the.
I can't read and I can't write because that don't really matter.
I thought
I'll tell you what, I'd struggle to drive my brother's tractors. It's like the bridge of the Starship Enterprise. I wouldn't know where to fucking start.
Oh, the modern ones, yeah.
Yeah, I mean, Dad's ones, they were great because you got in, you got the engine running, and the first putting it in gear for the first time that day was always an issue. There was always lots of go on, get there, you bugger. That make lots of grinding noises. And once you got it in gear, the gearbox thought, "Oh, I've got to work today." Okay, you're fine now. But that first time, it was like, I mean, brothers, you get in, you turn the ignition on. There are little multicoloured LCD screens everywhere, and it's like, where's the warp drive button? You know, it's just,
I like Blue's
switches.
background on his green screen. Looks like a room with a light on and a picture.
And he's muted.
Yeah,
There we go.
I'm not muted. I just was talking
Yeah,
softly.
Oh dear.
Okay,
Nice one, mate.
there's plan B. What's the next one? Shit be gone. There we go.
Push play, but
Speaking
Yes,
of
Laura, I am also farmer's brother.
speaking of toilet paper, there was none in the shop again the other day.
yeah, I know.
Really?
Crikey. Yeah.
Yeah. Yeah, the whole aisle's empty.
Yeah.
Oh.
Yeah,
What?
the shortage. Customers saying, sorry, no toilet paper.
Well, they're even having
only
trouble.
thing-
They're even having trouble in other places where there's shortages of actual just normal goods, frozen goods, and that in some of these other outback countries, outback towns.
The only thing I'm struggling to buy at the moment is orange juice.
Orange juice?
Every time I go shopping, I think I'll get some orange juice this time. You go and have a look. No orange
No
juice,
orange
or
juice.
not. You know, just the ordinary smooth stuff because I don't like orange juice with bits in it.
Well, if you're Russian, you need vodka and orange.
Oh, don't worry, I've still got some vodka.
Apparently, Western Australia here is run out of is having severe shortages of dairy products and meat products because they get a lot of that stuff from the eastern states, and the railway lines through South Australia have been flooded out.
Yeah, I've
So
seen
they
that
can't-
on the news.
They literally can't deliver them for a couple of weeks.
Yeah, see the railway lines are leaning down, sliding down the hillside.
Yeah.
I can see how that would not be good.
Yeah, trains don't work on an angle for some reason.
No, they don't like too much of a slope, do they? They don't have much in the way of grip.
Is that the only pictures we had? Yeah, that was it. That's all we had. What's that?
Oh, dear.
Oh, I've got to scroll back up again. Ah. Today, scientists see something T was responsible for discovering a number of asteroids and minor planets, and was a supporter of doing research to better understand UFOs. And
Yeah.
who started guessing that? Clive did he? Did
Clive
Clive
got
get it
it
straight
first.
away, probably?
Yeah. Yeah, go on,
He did.
Clive.
You said, yep, that's him. Damn you, Clive, Wolfie said. Nah, don't miss out on the other. What happened to me? Who was pressing random buttons? Delirium wanted to know. Am I out of
Press
time out
random
yet out there, Peanuts?
We don't press random buttons. To start, press any key. Where's the any key?
You where's the any key? I've never found it yet.
Somebody tell me where it is. Where's the any key?
Yeah. Okay, I've got to go back here. Now, I wasn't able to expand my side to make the Peanuts read it. For me to read much, I don't think. I forgot how much. I don't know if I can read that. Well, that might work. No, that won't. But that may. Now I've got to scroll up to where we started. Uh, 2007 construction detail design, I think we're up to.
Yep. Yeah.
Oh,
I think that's
get
where
back
we said
down
we'd
there.
go from.
Trying to scroll just a little bit, so I won't do it. Somebody's pressing random keys in the peanut gallery and came out. What?
Oh yeah. Well, either that, or they've just sneezed.
I'm sorry, I'm not laughing at that. I'm looking at funny bumper stickers.
Oh, yeah.
There's one here that says, "Lost your cat? Try looking under my tyres."
Yeah.
Oh, ouch. Ouch. Oh, mate.
I've had to dispose of the effects of that, and I have unfortunately actually done it myself. I had a cat try to commit suicide right in front of its owner, who was out doing his garden. And just as I was about to drive past, the cat jumped out in front of me.
I was doing my driving lesson back in the day, and I ran over a dog
Yeah.
while
I've hit a
I was
couple of
doing the
cats,
driving
but
lesson.
I generally tend to hit sort of more varied wildlife like hares and pheasants, and I did clip a deer once, but he barely noticed. He carried on running. I thought, oh, you're all right. Then you managed to run away. You can't be that badly hurt.
And the driving instructor commended me of not avoiding to run over it by driving around it or whatever, because he said if you do that to avoid it, you could have hit an oncoming car or things like that.
Oh, yeah. You're better off hitting something soft and squidgy. Does less damage.
Unless it's a human.
Well,
Or
they can cause a bit more damage.
Or a wombat.
But I didn't think wombats were soft and squidgy.
No, I know.
Depends how fast you're going when you hit the buggers.
They put me mate's HZ wagon into the ditch. He had he was following some blokes up to a car show, and I think he might have been a little bit too close to the guy in front because he avoided the wombat, but me mate didn't.
Ah, yeah.
I did see photos once of a roe deer that went through the grill of a BMW. I think it was a 5 Series.
Mm-hmm.
You know where they've got the sort of like the two not quite circular bits either side in the centre. It
Yes.
had gone through one of those, and it completely filled the space, the remaining space that was in the engine compartment.
Yeah, I was thinking, yeah, I bet. Well,
God knows how fast he was going when he hit. The look with the bonnet shut, it didn't look like there was any issue with the car. Only after you opened the bonnet you could see how much damage was done.
hit a pheasant at 80 mile an hour and he just disappears. Hit a hare at 80 mile an hour, square on with your front wheel, and he just sticks to the underside of your car.
Dora said, "Do you have a barbecue after the lesson, Terry?" And I went, "No, it wasn't a sausage dog, Dora." So, are we ready?
Yeah.
Yeah.
We're ready.
What's that, mate?
I'll read the first paragraph.
Okey-dokey.
Construction detail design. If anyone out the Pinot Gallery doesn't know what we're doing the Space Telescope, the James Webb. In January 2007, 9 of the 10 technology. Get me words around. 9 of the 10 technology development items in the project successfully passed a non-advocate review. These technologies were deemed sufficiently mature to retire significant risks in the project. The remaining technology development item, the MIRI cryocooler, completed its technology maturation milestone in April 2007. I'll scroll up a bit more. Completed its technology maturation milestone in April 2007. This technology review represented the beginning step in the process that ultimately moved the project into its detailed design phase C, by May 2007. Costs were still on target in March 2008. The project successfully completed its preliminary design review, PDR, in April 2008. The project passed the non-advocate review. Other past reviews include the Integrated Science Instrument Module review in March 2009, the Optical Telescope Element review completed in October 2009, and the Sunshield review completed in January 2010.
Right then. In April 2010, the telescope passed the technical portion of its Mission Critical Design Review, or the MCDR. Passing the MCDR signified the integrated observatory can meet all science and engineering requirements for its mission. The MCDR encompassed all previous design reviews. The project schedule underwent review during the months following the MCDR in a process called the Independent Comprehensive Review Panel, which led to a replan of the mission aiming for a 2015 launch, but as late as 2018. Well, you weren't far out. By 2010, cost overruns were impacting other projects, though JWST itself remained on schedule. Such cheery optimism. By 2011, the JWST project was in the final design and fabrication phase, phase C. As is typical for a complex design that cannot be changed once launched, there are detailed reviews of every portion of design, construction, and proposed operation. New technological frontiers were pioneered by the project, and it passed its design reviews. In the 1990s, it was unknown if a telescope so large and of so low mass was possible. Assembly of the hexagonal segments of the primary mirror, which was done via robotic arm, began in November 2015 and was completed by the 3rd of February 2016. The secondary mirror was installed on the 3rd of March 2016. Final construction of the Webb telescope was completed in November 2016, after which extensive testing procedures began. In March 2018, NASA delayed the telescope's launch an additional year to May 2020, after the telescope sunshield ripped during a practice deployment and the sunshield's cables did not sufficiently tighten. In June 2018, NASA delayed the launch by an additional 10 months to March 2021, based on the assessment of the independent review board convened after the failed March 2018 test deployment. The review identified that the telescope launch and deployment had 344 potential single-point failures, which are tasks that had no alternative or means of recovery if unsuccessful, and therefore had to succeed for the telescope to work. In August 2019, the mechanical integration of the telescope was completed, something that was scheduled to be done 12 years before, in 2007.
Wow.
Yeah. But that highlights the problem with this thing. 344 potential things that could fail. That if any one of them failed, that's it. It's a million miles away. It's knackered. We can't do anything with it. So, After construction was completed, JWST underwent final trials at Northrop Grumman factory in Redondo Beach, California. A ship carrying the telescope left California on the 26th of September 2021, passed through the Panama Canal, and arrived in French Guiana on the 12th of October 2021. Just over 2 months later, it was launched.
Oh, so they launched it from the from Guyana, did they?
Yeah.
Down where ESA throws all the Arianes into space.
That's it. Yep.
So we'll skip all that other stuff in between. We'll go straight to orbit design.
But that figure again, I think that is worth highlighting. Because of the way the mirror's made and the heat shield and everything, because it all has to deploy and lock into place and everything else. 344 potential times it could go. Sorry. Just one of them is enough to stop it from working.
We'll have to look into the, is it Mylar or something different that they're using for the heat shield? Because I was saying that they ripped a bit of it accidentally, of course.
Yeah, I can't remember what it's made of, but yeah, all of these things are purely mechanical, and if any of them fail, there's nothing you can do. Because obviously, if it's electronics, if it's a software problem, then you can hopefully transmit a patch or a new program to it or anything like that. But if it's mechanical, we can't send somebody up there to clout it with a hammer. At least with the Hubble, it was within reach. This isn't. We haven't gone 1 million miles from Earth ourselves. 907,000 or whatever it ended up being. So the fact that it's got to where it is and so far everything's worked is quite something.
Now we're getting into the orbit design. I've got an image there. I'll see if I can open that up in a minute. You might be able to see that. I can't really... I could fiddle with it to make it better.
You're not showing it in Zoom, are you?
No,
I'll show it in Zoom. Yeah, I'll show it in Zoom.
There we go.
Alright, okay. So 130 million kilometres from the Sun we are, and it's expected to be 1.5 million kilometres away from Earth. It's not that far, really.
Well, nearly. It's not the Lagrange 2 point is 1.5 million kilometers, 930,000 miles. James Webb is, I think it's at 907,000 miles. So it's not quite at L2, but it's pretty damn close. So I think that's where it ended up. I think it's something like 907, 908,000 miles away. So it's just a little bit under 1 million miles.
Well, it actually orbits L2, doesn't it?
Yeah, I think it actually orbits L2 itself.
You can't just sit it out there and park it.
No.
Well, you can, but it's not going to stay there.
Yeah.
These images I'm trying to show, I can't make it go any higher. 2 alternate Hubble-based telescope views of the Carina Nebula, comparing ultraviolet and visible top and infrared bottom.
Yeah. So the bottom one is the sort of thing they're liable. That's the sort of image you're going to get from the James Webb.
Because it shows a lot more stars, that's for sure.
Well, yeah, because it's infrared. I mean, the Hubble the Hubble photographs are more on the visual spectrum, so you get lots and lots of pretty photos.
Yeah, visual and UV, I think, whereas this is IR.
Yeah.
But of course, because of the huge amount of redshift the really early stuff has, infrared is where you need to be looking for it.
Yes.
Because that's all that's getting to us now, thanks to the redshift.
Okay. I could probably manage reading down to there, maybe.
Okay.
I should be able to. I know my eyes are going to blow out pretty quick.
Do you want to actually do the little bit above it first, though?
Oh, the mission
That
goal
bit.
up here.
The mission goals. I think that's quite a...
Okay, mission goals. The James Webb Space Telescope has 4 key goals. To search for light from the first stars and galaxies that formed in the universe after the Big Bang. To study galaxy formation and evolution. To understand star formation and planet formation. To study planetary systems and the origin of life. Whoa. Okay. These goals can be accomplished more effectively by observation in near-infrared light rather than light in the visible part of the spectrum. For this reason, JWST's instruments will not measure visible or ultraviolet light like the Hubble telescope, but will have a much greater capacity to perform infrared astronomy. JWST will be sensitive to a range of wavelengths from, is that 0.6 to 28?
micrometers.
Somebody told me what that funny looking U and
Yeah.
M meant once before.
Yeah,
didn't you?
that's micro.
Because normally we talk about wavelengths of visible light in nanometers, which is 10 to the minus 9 meter, 10 to the minus 9, whereas micro is 10 to the minus 6.
Mm.
So a decimal point and then 6 zeros before you start.
Can we get an example of the wavelength of what something is now and that we can compare it to for what this is saying?
Well, the 0.6 micrometers corresponds to 600 nanometers, which is kind of orangey red light, and 28 micrometers is well into the near infrared.
Right.
So we can't see that because it's it would be 2,800 nanometers.
Okay, they're saying corresponding respectively to orange light and deep infrared radiation at about, is that 100 Kelvin or minus 173 degrees C. JWST may be used to gather information on the dimming light of a star, that one there, KIC 8462852. Wish they'd just give it a name and it'd make it a lot easier.
That's a snap. Yeah, but there's so many out there.
Which was discovered in 2015 and has had some abnormal light curve properties. Oh. Okay. Alright, orbit
So
design.
it's weird stuff then.
Yeah. Well, they'll be able to look at it now and figure out what's going on.
Well, yeah, that's the thing. It's good to be able to look at the weird stuff, isn't it?
Okay, Dora gave a comparison. We see 600 to 800 NM-ish. I'm off to get some sleep. Have fun, everyone. Okay, Jinx, you.
Not Jinx.
It'll be start a bit
Yeah,
late
Jinx.
for you, Jinx.
Probably.
24-hour days. Oh yeah, they kill. Oof. Sod there.
Where was I? Oh, orbit design was I up to now?
Yeah.
Can you go from my Isaac?
Yeah, of course I can.
Because I read the chat and that's white on black, and then I go over to that and that's black on white. Ruins me eyes. Bloody ruins me eyes doing that.
Yeah, no worries. Right, the JWST orbits the Sun near the second Lagrange point of the Sun-Earth system, which is 1.5 million kilometres, or 930,000 miles, farther from the Sun than the Earth's orbit, and about 4 times farther than the Moon's orbit.
You're going to say fart.
Normally, far. I was going to say further, but it is farther. Normally, an object circling the Sun farther out than Earth would take longer than 1 year to complete its orbit. But near the L2 point, the combined gravitational pull of the Earth and the Sun allow a spacecraft to orbit the Sun in the same time that it takes the Earth. Staying closer to Earth also allows data rates to be much faster for a given size of antenna. The telescope circles about the Sun-Earth L2 point in a halo orbit, which is inclined with respect to the ecliptic. So that means it's not going round like everything else is on the plane of the ecliptic. It's going the other way.
Oh, okay.
Yeah. It's also it's at an angle. It's not sort of straight 90 degrees. It's has a radius varying between about 250,000 kilometers and 832,000 kilometers. So that's between 160,000 and 517,000 miles. It takes about half a year to complete. Since L2 is just an equilibrium point with no gravitational pull, a halo orbit is not an orbit in the usual sense. The spacecraft is actually in orbit around the Sun, and the halo orbit can be thought of as a controlled drifting to remain in the vicinity of the L2 point. This requires some station keeping, around 2.5 meters per second per year, from the total delta V budget of 93 meters per second. 2 sets of thrusters constitute the observatory's propulsion system. Because the thrusters are located solely on the sun-facing side of the observatory, all station-keeping operations are designed to slightly undershoot the required amount of thrust in order to avoid pushing the JWST beyond the semi-stable L2 point, a situation which would be unrecoverable. Randy Kilburn, I love the name Randy. Hi, I'm Randy. Randy Kimball, the integration and test project scientist for the James Webb Space Telescope, compared the precise station keeping of the telescope to Sisyphus rolling this rock up the gentle slope near the top of the hill. We never wanted to roll over the crest and get away from him. 10 points if you can remember who Sisyphus was. So yes,
the story, but not the names.
Yeah, it's a strange orbit this thing is in, but this leads to one of the problems with the James Webb Space Telescope. It has to adjust its position in this orbit, and it can do that by firing its thrusters, which means at some point it's going to run out of fuel.
Yeah.
Once it runs out of fuel, it will drift out of position. They then can't use it. So this isn't where you can just sort of park it somewhere and it quite happily sit there for the next 50 years. It won't do that.
Unlike
because L1 and L2 and L3 are unstable Lagrange points. They're not stable, which means that any object that you don't have thrusters on will tend to drift away from the L2 point. Yeah.
I think originally they'd anticipated that it might have enough fuel the last 10 years. They're now hoping it could go longer than that. But inevitably, at some point, it will run out of fuel. And it's not like we can just nip up there and get a jerry can out and top it up.
Yeah.
Once it's gone, it's gone, you know.
Why not?
That's
Just
why
send
they
a
were
space shuttle up there.
That's also why they were so excited that because they didn't need to use much fuel to actually get it into its proper place.
Yeah.
They've got more fuel for the manoeuvring, which means that they can use it for longer.
Yeah, I think I saw somewhere they were hoping it might go an additional, maybe even 5 or 10 years more, but I guess you won't really know until you've been using it for a few years and see how it's going, see how much fuel it's used and how much is left. But I suppose also by then, once this thing's run out of fuel, they'll have designed, built and launched its replacement, or they'll be concentrating on something else. Who knows?
In theory, can it be put up into space and be stagnant in one spot?
Only if you put it in one of the stable Lagrange points, L4 and L5, which are 60 degrees ahead and 60 degrees behind the position of the Earth in relation to the Sun. They are stable points, which means that if the spaceship goes out of position, the actual forces can contrive to pull it back into that position. So it's like putting a marble in a bowl, a bowl shape. If you move the marble away from the centre, it will automatically go back towards the centre. However, the L1, L2 and L3 points are more like an inverted bowl with the marble right at the top.
Oh.
In that it only takes a little bit of a push, and the spacecraft will move away from the centre, and you have to, like Farmer's Boy said, do station keeping to keep it at that point. As long as you keep it at that point, the orbit will keep it in that. The forces of the Earth and the Sun will contrive to keep it in that same location, like it'll orbit at the same period as the Earth. But as soon as it goes away from that point, it's not a stable point. It will actually drift faster and faster away from that point if you don't boost it back into that point.
Wow.
Oh, Terry, we have a naked person in the chat.
Yeah, I see
Oh,
they're
yes.
naked. Spanner for a sub. That's the deal.
I mean, a lot of the things that we do put into space do need some form of station keeping, like the ISS has to adjust itself. The thing is with the ISS, it's we have to keep resupplying the ISS. So although it has quite a reserve of fuel on board anyway, we can top it up. We can send it up with a resupply mission. So if they do get low on fuel for their thruster systems, we can top them up again. The James Webb has gone all this way out, nearly a million miles away. We don't have anything that we can send out there to top it up again.
I haven't read anywhere.
Sorry, go on.
No, I was just going to ask. We haven't read anywhere yet of why they have to send it so far away.
The sun.
Oh.
It's not that. It's to do with, like, the reason why they've chosen the Lagrange point is because it's a stable orbit. It means that it's in that position in relation to the Earth and the Sun all the time. It's kind of like a geostationary orbit, except it's not. It's not a geostationary orbit, but it's kind of like a geostationary orbit in relation to the Earth-Sun system together. Yeah. Whereas the Hubble telescope, because it's in low Earth orbit, it's orbiting around the Earth at quite a rate, and it takes quite some manoeuvring to be able to point it stably, consistently at a particular location. There have to be some, quite complex gymnastics to achieve that. So having it at L2 sort of makes that a little bit easier. And also because it's away from a lot of the infrared sources on the Earth.
And it won't be pointing anywhere near the sun, will it? It'll be always.
No.
Its field of view will always be away from the sun.
Yes.
They had to take that into account when they actually launched it. It's launched in its trajectory to L2. They had to minimise interference, shall we say, from the sun just on the launch and the way out there. This thing's so sensitive that the sun could really screw it up.
Damage it.
Yeah, damage it. Yeah, not just impinge on it, but fuck it up. Basically, it's.
Yeah.
I mean, that's why most of the James Webb Telescope is this huge multi-layered sun shield. Is to keep it so it doesn't get affected by the heat, the infrared coming off the sun.
A big old parasol.
It is a big old parasol, but that's I mean, that's how important it is to keep it away from the heat of the sun.
Do we remember where we were up to?
The next bit would be infrared astronomy. Astronomy Domini.
Oh, where have we read to?
We got down to the bit with Sisyphus. And there's an animation actually showing from three different views the actual orbit of the telescope around the L2 point.
With, I'm guessing, the blue dot being Earth.
Yes.
Wow.
And as that says top view, I'm guessing that's with Earth us looking down at the North Pole of the Earth.
I think so, yes.
This is side view.
So that would be with North Pole at the top of the little blue dot.
It's a damn mess.
Isn't it?
It's like trying to draw on one of those Etch-a-Sketch.
Oh, God, yes, I had one of them when I was a kid. That was just so frustrating.
And the next one, side view from the sun.
So you can see it's at a sort of 30 or 40 degree angle to the plane of the ecliptic, which is roughly the orbit the planets take. So they're sort of going round. They'd be going around from the two sort of arrows at either side. If you imagine that's the plane of the ecliptic, and this is orbiting at an angle round the other way.
So we're up to here, are we?
Yep, infrared astronomy. Hang on, let's have a slurp. Right then. So the James Webb Space Telescope is the formal successor to the Hubble Space Telescope. And since its primary emphasis is on infrared astronomy, it is also a successor to the Spitzer Space Telescope. JWST will far surpass both these telescopes, being able to see many more and much older stars and galaxies. Observing in the infrared spectrum is a key technique to achieving this because of cosmological redshift and because it better penetrates obscuring dust and gas. This allows observation of dimmer, cooler objects. Since water vapor and carbon dioxide in the Earth's atmosphere strongly absorbs most infrared, ground-based infrared astronomy is limited to narrow wavelength ranges where the atmosphere absorbs less strongly. Additionally, the atmosphere itself radiates in the infrared spectrum, often overwhelming light from the object being observed. This makes a space telescope preferable for infrared observations. The more distant an object is, the younger it appears. Its light has taken longer to reach human observers. Because the universe is expanding, as the light travels, it becomes redshifted, and objects at extreme distances are therefore easy to see if viewed in the infrared. JWST's infrared capabilities are expected to let it see back in time to the first galaxies forming just a few 100 million years after the Big Bang. Infrared radiation can pass more freely through regions of cosmic dust that scatter visible light. Observations in infrared allow the study of objects and regions of space which be obscured by the gas and dust in the visible spectrum, such as the molecular clouds where stars are born, and the circumstellar disks that give rise to planets, and the cores of active galaxies. Relatively cool objects, temperatures less than several thousand degrees, emit their radiation primarily in the infrared, as described by Planck's law. As a result, most objects that are cooler than stars are better studied in the infrared. This includes the clouds of the interstellar medium, brown dwarfs, planets both in our own and other solar systems, comets, and Kuiper Belt objects that will be observed with the mid-infrared instrument, the MIRI. Some of the missions in infrared astronomy that impacted JWST development were Spitzer and the Wilkinson Microwave Anisotropy Probe. God, put my teeth in. Spitzer showed the importance of mid-infrared, which is helpful for tasks such as observing dust disks around stars. Also, the WMAP probe showed that the universe was lit up at redshift 17, further underscoring the importance of the mid-infrared. Both these missions were launched in the early 2000s and timed to influence the James Webb Telescope's development. And what are you playing with, Terry?
I'm trying to get that image that was on the side. Trying to get it
Oh,
so I can
yeah.
show it. But it's not, I can't get it small enough or in the right spot. I've got it saved as an image, but I couldn't get it to fit for some reason.
But fitting now. Now you've made it go full screen.
That's
Yeah.
full screen.
Ah, but you've not quite got the full screen on what's going out to YouTube, have you?
No, I can't get it to fit the right, because that's 100%, and then I could scroll down if I swap it to that one. Radio transmitted by the atmosphere. Spectral intensity. Incoming solar radiation. I've got no idea what any of this means, obviously.
That's what's coming from the sun, Terry.
Yeah, incoming solar radiation. Yeah, I understand that.
Yeah.
And outgoing thermal radiation.
Hmm.
Yeah. All the heat we're giving off.
And then we got percentage of total absorption scattering. Water vapour, carbon dioxide, oxygen, ozone, methane, nitrous oxide, Rayleigh scattering. I've heard of Rayleigh scattering before.
Yeah,
I've
yeah,
heard
funny that, eh?
Isn't it interesting in that total absorption and scattering graph that there is a big gap just at the wavelengths that we're giving off?
Yeah.
What, over there?
Rayleigh
Oh, you
scattering.
can't see me mouse over there. Yeah. Yes.
Rayleigh scattering's got Rayleigh scattering's got something to do with rubber bands and cows, doesn't it?
I think so, yeah.
I think so, yeah. No, isn't the Rayleigh scattering the rubber bands and the methane the cows?
Yeah. Well spotted, yes, of course, yes.
I mean, you could possibly blame some of the CO2 on the cows too, but you know.
Yeah, I think it's more methane than anything else, yeah.
It's the methane.
And it is, you do get a surprising amount of methane off large herds of cows.
Yeah, imagine the atmosphere back in the day of the dinosaurs. Like that image in Jurassic Park when there's a big pile of poo there.
Yeah, oh, that's right, yeah.
Yeah,
Yeah,
but let's face
Triceratops.
it. Once upon a time, our atmosphere was almost completely carbon dioxide, with only a little O2.
I think it's also been argued that at several points there was more oxygen in the atmosphere, and
Oh,
that
yeah.
might have assisted in the dinosaurs getting to the size that they did.
Yeah.
Yeah, but I'm talking much earlier.
Oh,
Because pre-life on this planet, it was almost all oxygen, and then some bacteria came along. I think it was bacteria came along that took in the CO2, and pumped out this gas that was buttering up the atmosphere called oxygen.
yes.
Almost completely reversed the ratios of CO2 to oxygen on the planet.
Yeah, that's what. Yeah, Ken Hovind says the dinosaurs killed themselves by farting.
I think also I think a lot of the carbon got locked in, didn't it? I think that's isn't that why the Carboniferous is called that age in particular?
Oh, I don't remember that.
It's a while since I've read up on it, but I think a lot of the carbon sort of got locked in the ground, and that's one of the reasons why we ended up having a high percentage of oxygen in the atmosphere, and they think that's why certainly dinosaurs back then could grow to the sort of size they were, because there was enough oxygen to support them.
Remember, I'm doing this from memory, and from watching a documentary somewhere. So it's very, very top left.
Yeah, no, it's a while since I've looked at it, I must admit.
Oh, I didn't show these images. I forgot.
But sometimes it's okay to be top left as long as you realise you are.
That's the trick.
Well, there you
The
go.
first
you
secret
go.
to top left is knowing that you are top left.
That gives you a good idea of the size comparison to the person when they
Yeah.
unfold the shield.
I don't think the percentage of carbon dioxide has ever been as high as you think it has, Alan. It's been higher than it is today, but not almost 100% by any means. I think the highest it's ever gotten is around about 3,000 parts per million.
Yeah, because our atmosphere is primarily nitrogen, isn't it?
Yeah, that's right.
I think it's been primarily nitrogen since
Yeah.
It's the other it's the other little the smaller amounts of gases that have
buried.
My understanding was it was the sort of the oxygen CO2 balance went from what was originally more like it was CO2 and oxygen were reversed back then to compared with what they are now.
Yeah.
Was my understanding, and I'm sorry I didn't get that across correctly.
Where are we up to, Farmer?
The next section would be ground support and operations. There you go.
That'll be exact section. Oh,
Couple of paragraphs.
yeah, an image popped up in my road. And mission progress from launch onwards. How's that been? Okay. I think we'll just read the next section and that'll be it for this.
Yeah, that seems a logical point to get to. Yeah.
I don't believe it. I don't believe any of this. These guys are just making this shit up.
Oh God, it's finally got to him. He's become a flat earther. Oh no. I suppose with the amount of exposure he's had, it was bound to happen at some point.
Yeah, it's bound to have happened. It got to him in the end. Then. It wore him down.
Ground support and operations. This is good old ground control. The snappily named Space Telescope Science Institute in Baltimore, Maryland, on the Homewood campus of the Johns Hopkins University, was selected as the Science and Operations Center for JWST, with an initial budget of $162.2 million. Not buy enough tea.
That's not much.
Intended to, $162.2 million.
Yeah, that's not a lot, really.
Yeah.
Tea and donuts. Job done.
Is that all in pencils and sharpeners and paper?
That's it. Pads of paper. Yeah. Intended to support operations through the first year after launch. Okay, we spent the money now. We're going home. In this capacity, STSCL will be responsible for the scientific operation of the telescope and delivery of data products to the astronomical community. Data will be transmitted from the telescope to the ground via the NASA Deep Space Network, processed and calibrated at the Institute, and then distributed online to astronomers worldwide. Similar to how Hubble is operated, anyone, anywhere in the world will be allowed to submit proposals for observations. Each year, several committees of astronomers will peer review the submitted proposals to select the projects to observe in the coming year. The authors of the chosen proposals will typically have 1 year of private access to the new observations, after which the data will become publicly available for download by anyone from the online archive at the Institute. The bandwidth and digital throughput of the satellite is designed to operate at 458 gigabits of data per day for the length of the mission. That's equivalent to a sustained rate of 5.42 megabits per second. Most of the data processing on the telescope is done by conventional single-board computers. The conversion of the analog science data to digital form is performed by the custom-built Sidecar ASIC, which is, as we all know, the system for image digitation. Oh, for fuck's sake. My teeth are gone.
Okay.
Which is kind of embarrassing because they're all my own. Digitization, enhancement, control, and retrieval application-specific integrated circuit.
Oh, jeez.
Why couldn't I just call it Fred? Just call it Fred and be done with it, eh?
Yeah.
They called it Sidecar ASIC to be done with it.
Fred. Jim. That's even better. Jim, it's only got 3 letters in.
Yeah.
NASA stated that the sidecar ASIC will include all the functions of a 9.1 kilogram instrument box in a 3 centimeter package and consume only 11 milliwatts of power. Blimey, that's good going.
Oh, milliwatts, yeah.
Yeah, I mean, that's nothing. Since this conversion must be done close to the detectors on the cool side of the telescope, the low power use of this IC will be crucial for maintaining the low temperature required for optimal operation of the telescope. Now, that's a very good point. So you've built this telescope that's it's got a huge multi-layer heat shield to keep it away from the heat of the sun. And you've then got to make sure that everything that's running the telescope also doesn't start generating too much heat and interfere with the telescope.
Yeah.
Because I think I saw at one point it has to run at around that minus 170 or so degrees.
Yeah, it's got to run at about 100 Kelvin-ish. Otherwise, the telescope won't work as it's supposed to. So yeah, you've made a telescope that will run this cold, and then you have the computer that's sort of analysing the data, chucking out heat. Yeah, not a good idea.
Yeah, I mean, given how well the computer and monitors keep my room warm.
Yeah, that's always been a factor. If I'm designing, say, an air conditioning system for an office, it's not just how many people are in there, because God knows we all give off enough heat ourselves. Oh yes, so they've all got a computer, they've all got at least one monitor, they all give off heat. All of a sudden, you don't care if it's a sunny day outside; all the heat's being generated indoors.
Yeah, it's about a kilowatt per person, isn't it? I think.
People give off a lot of heat.
Just sitting
600 watts or so.
Yeah, sitting at your desk, you are giving off roughly 110 watts of sensible heat. So that's more heat than a 100-watt light bulb. Now, if anybody has still got ordinary light bulbs left in our bloody houses, and a 100-watt one in, say, your angle poise lamp, turn that on and then put your hand near it and feel the heat coming off it. You're putting off more heat than that just sitting still doing sod all.
Wow.
Yeah.
It's a similar situation with like the company I work for. They hatch about 120,000 ducks a week, right?
Yep.
So they've got some fairly big incubators that hold a lot of eggs, and an important part of those incubators is the chillers. You think, well, what the hell do you need chillers for in an incubator? Aren't you supposed to keep it at like 38 degrees? You're supposed to be heating up the eggs. But there comes a point when you've got like tens of thousands of eggs in an incubator.
Yeah.
At a certain stage of their development, they actually give off heat, and you actually have to cool the incubators down so that the eggs don't overheat. Yeah.
Yeah.
Or you end up with pre-cooked ducks.
Yeah, that's right. Yep.
Very small pre-cooked ducks. Yeah, they ain't gonna be a lot of use. Oh yeah, we used to have when Dad kept pigs, we used to have big infrared bulbs to put heat into the areas where the piglets were. Yeah, when they were still quite small and young, and in the end, we used one of them to stop the downstairs toilet U-bend from freezing up during the winter, because there was no heat in the downstairs loo. So an infrared bulb held to the side of the U-bend with baling twine, of course. Stop the toilet from icing up.
So remember, we're up to mission progress from launch onwards.
That's it, mission. Yep.
Okay. Alright. Get rid of that. I can close that altogether now.
That's it.
Alright, that's gone. Alright. What else are we haven't planned for?
Oh yes, I sort of had remembered, right. The Carboniferous period is when everything was laid down that became coal,
Right.
and that's why the carbon dioxide levels in the atmosphere dropped, because all that carbon was getting locked in.
You've been Googling, haven't you?
Well, I was fairly certain I remembered why it was called the Carboniferous, but I thought I'd better just check. Because I read it somewhere ages ago. But yeah, I think that's what led to the oxygen level, the proportion of it going up. I think they're fairly certain that's why dinosaurs could get to the size they were, because there was more oxygen in the air. I think when you watch something like Jurassic Park now, and even if they did manage somehow through the wonders of genetic engineering get us a brachiosaurus, I don't think it would last very long, because there just wouldn't be enough oxygen in the atmosphere for the poor bugger to survive.
Yeah, carboniferous. I can see the connection.
Yeah, that's when we got all the basically everything laid down that became the huge coal deposits we've been digging up and burning, putting all that carbon back into the air.
Now I've got to grab that after Phil's one.
Oh, there we go. There's the figure I was looking for. Yeah, by the end of the Carboniferous, they reckon the oxygen levels in the atmosphere was approaching 35%, and today we have about 21%. So there was much more oxygen in the air.
Oh, Blue done a live stream. How long did that go for?
He did.
How long did that go for? I must have missed out on that one.
It's not. It's still processing. Terry.
Oh, is it? Yeah. Okay. You did one. Try thinking late positron truth bending.
Yeah.
I'll watch that later. We'll watch that after. That's not what I was looking for, but I'll grab it while I've. Oh, that's live in 2 days. You haven't got anything more recent? I can't see anything.
What did I do the other day?
I don't know what you do the other day. Oakley QE curved adjacent nonsense. There's that one.
You did something the other day, didn't you? Mm-hmm.
That was on the 26th.
Did we watch that?
Wednesday. Well, I didn't stream Wednesday.
You did the curved adjacent, didn't you?
Yeah.
Yeah, we didn't watch
and
that.
that was 3 days ago, so we won't watch that because obviously we didn't do anything on Wednesday, did we?
No, so I'll grab that one.
So yeah, we haven't watched that one.
No, I haven't watched that.
Well,
the only live debate I can find with some stupid in it, because we did Lindsay last time, so we'll do a stupid this one.
Oh no, we're not doing Lindsay. Oh.
Well, I've been.
What a shame.
Yeah, but this debate's with somebody we all know. Where is he? I'll just scroll up for him. I know fight the flat Earth. You can give or take him, but
he did one the other day with Flat Out, was it?
Flat Out Hero.
Flat Earth
Yeah,
Hero.
I thought. Well, we all know Flat Out Hero, so I'll grab that. I know it goes for 3 hours, but I just want to get the gist of the debate.
Yeah, because he said he'd become he wasn't a flat earther anymore. It turns out it was all bollocks.
Yeah. Which is weird.
Yeah, but is he the sanest individual you've ever listened to?
Well, this is what we're going to find out. So we'll skip it ahead a little bit. Get the introduction part out of the road. Okay. Share it to you guys. So we'll do jumps all the way through. We'll keep an eye on the timer for about 10 minutes ish of this. So you want that. Right, you want that.
Phil had a question in the chat.
Did he? Well, let me find it.
Yeah, Phil said, where would the energy come from? Ask Paul, but...
What's that for?
I'm guessing to do with the eggs getting hot, warm, heating up, whatever.
Oh well, I mean, it's biological processes. I mean, the eggs do absorb oxygen, so there is, you know, something going on inside the eggs there that gives off heat.
What was the question
It
or the
is a-
thing that he's relating to, Paul?
Where would the energy come from to make the eggs warm? Well, from inside the egg. I mean, there are biological processes converting the contents of the egg into a biological life form, and I guess that gives off energy.
Probably some exothermic chemical reactions.
Yeah. Remember, eggshells are porous and they do let oxygen in. That's how come the ducks can develop and survive.
Peanuts know that they can jump into the Discord if they don't want to come on here, if they want to ask a question live. So they don't have to read it out all the
Yep.
time. That's their choice. If you haven't got the link for the Discord, I'll redo it for you. Here we go.
Yeah, but self-sorting eggs would interest Riley.
Self-salting.
Self-sorting. Yeah.
Yeah, that's not bad. I like that.
Yeah, self-eating eggs, a brilliant invention. Why isn't that playing?
I find most of the
Oh,
people I
shit.
debate about Flat Earth on Facebook, where they have Facebook accounts where they talk to people on Facebook.
That was a bit
Not
loud.
everybody who is a Flat Earther has a YouTube channel to talk about Flat Earth, but I invite them on to debates, and they
How come they
come.
don't get flat Earth points ever?
They attempt to. Every single one of them attempt to, but there is no Flat Earth points. There is no Flat Earth map. There is no Flat Earth model. There is no Flat Earth explanation for natural phenomenon that we experience throughout the world.
How come they respond to you, but they don't respond to any flat Earthers?
What, like who?
Like me.
Well, when did you speak to them?
Well, I tried to fucking speak to fucking whoever it was the night the person you debated before me last time. Whoever that was.
Hillside, was that?
I forget the name. It wasn't Hillside. It was somebody else. It was something. I don't remember. It was fucking. I just tried to contact him. I never got anything back from him.
How did you try to contact him?
MC Tunes. I tried to contact MC Tunes debate person, and I couldn't get in contact with them. And I checked.
Yeah,
both
yeah.
these
How did you try to contact them?
over YouTube.
Yeah, they don't have YouTube channels like we just discussed.
No,
So
they
yeah,
do.
the person I debated before you was Hillside. Before that, it was Brother Sanchez. Is that who you're talking about?
They're debating from their YouTube channels.
Well, Brother Sanchez definitely debated me from his YouTube channel. Is that the one you're talking about?
How do you debate from not a YouTube channel?
You're not debating from a YouTube channel right now. You're debating me on Zoom.
But okay, all right, I see.
Yeah,
Well-
but Brother Sanchez was also streaming to one of his YouTube channels.
If he goes to
He was
be
the
a
one in the
global,
studio and stuff. Is that the one you're talking about?
vote in the peanut
No,
gallery
it's
if you
Brother
want
Sanchez. It was
want him to be on our
whoever
side.
right before me.
Gleason?
Neeson? Maybe.
Gleason.
No.
Well, before you, the last person I debated was Hillside. Before that, it was Brother Sanchez. Before that, it was Gleason.
Maybe Gleason, that sounds familiar.
Well, Gleason
But-
claims to have been someone that has been debunking and destroying Globers for 5 years. Says that we don't understand the Flat Earth model, yet doesn't give a Flat Earth model. When I asked for the model, he said the UN logo. But he is most definitely a Flat Earther, because he is all over the Flat Earth Facebook groups all of the time, saying that he's destroying Globers.
Does he have a YouTube channel?
No, he does not.
Well, whoever it was, I contacted them on their YouTube channel.
Well, the only one that I've debated recently that had a YouTube channel was Brother Sanchez.
I don't know, maybe it was. I don't know.
Yeah, so what you're doing right now is called the no true Scotsman's fallacy. Oh, they're not a real flat earther, therefore you don't debate flat earthers. I'm the real flat earther. It's only a real flat earther if they've got a YouTube channel and talk about flat earth. That's called the no true Scotsman fallacy, where only your specific definition of something is correct. Everyone that I bring on this channel, whether they are a Poe or not, tells me that they think the Earth is flat, and that's why I invite them on this channel. I don't limit myself to people with flat Earth, with YouTube channels, because a lot of them are far too scared.
What's a Poe?
A Poe is someone who pretends to be a flat earther for whatever reasons, or just in general, a Poe is someone that pretends to be something they're not, to troll people, or for attention or whatever. Research Poe's law. That's the.
You got to be kidding. He doesn't know what a Poe is.
So many years in this,
of course he knows what a
Poe is. I'm sure you've been called one several times.
Poe right now.
But yeah. So anyway, I don't lie.
What, he's going to try to pretend he's a glober now, is he?
No, I think he's done that. He did that a little while back, and then obviously went back to being a flat earther because he never was. He always was a flat earther.
We'll see how he goes. See if he knows our model then.
If they say they're flat earther, I bring them on to debate. You specifically lied just to kind of garner attention and do something.
Well, for what purpose would I be garnering attention for?
Well, because you want lots of subscribers.
For what?
So that you can spread the flat Earth truth.
Oh, okay. So it's not for money, right?
Well, you clearly need money because you owe $100,000. But anyway,
clearly I couldn't get any money because I'm monetized, but I've got over 1 million views, and I've got no money for it.
1 million views?
Yeah, because you weren't monetized at that point.
I've been monetized the entire time.
Yeah, no, you weren't monetized to start with. You only got monetized after that big video that allowed you to reach the monetization criteria, and unfortunately that big video was the thing that gave you that monetization criteria.
No, okay, fine. Let's say that that's right, because that probably is actually right. But now I had I had basically no subscribers until then. Then once I got to the 1,000, then I got the views. My views after that have been way more than enough to fucking get money, but I'm censored. I can't get money.
Of course. That's that. YouTube don't pay money for revenue. Right. Okay. Anyway, so you lied. Your excuse for lying is what? What was the reason that you lied to everybody and pretended? I mean, nobody believed you. Not even me. Literally nobody believed you. Me and everyone else need to be welcoming to anybody that claims to be an ex-flat earther, because we don't want people that are on the fence to feel like they can't come out. So anybody, even a liar like you, that claims that they are no longer a flat earther, we will be welcoming to and say, well, welcome back. I'm glad and any more questions, and be willing to help you.
I'll later date.
It's flat, you never go back. That's why you got nobody doing that except for Ranty.
Except for the entire playlist of ex-flat earther interviews that I have on my channel, of course.
Like Ranty, who I called out before he ever decided to use.
Ranty was again, you're doing the no true Scotsman fallacy. Ranty was most definitely a flat earther. He had absolutely convinced himself the Earth was flat.
I called him out before he ever.
So you were stupid before you were stupid. Good job.
No, I called him out that he was a baller, and he turned out to be a fucking baller.
Only he became a baller. Well, baller is not really what we are. A normal person is the correct term. But he was always a flat earther, and he had a legion of flat earth fans that followed and used his examples to say that the Earth was flat.
Yeah, his experiments I called out because they were fucking experiments.
You mean his observations of boats going over a curve?
Observations I had already done, and I knew what he was fudging on it.
What was he fudging?
Well, for like the distance, the horizon one, for instance, he was putting his camera way above the ground. He was not putting it at the center of the camera at the level of the ground like an ant.
He always said what his observer height was. That was one thing he
at
always
the level of the ground. How are you supposed to do that with the camera? What, stick the camera in the water?
And put it above the horizon.
Oh, you have to dig a hole.
Of course, the observer height works when you put it above the horizon. That's what your observer height is. Anyway, you lied. I just wanted to make sure that we all know why you lied. But let's let people know why you're here today, shall we?
The right perspective, but other than that, no, he was not doing the right perspective.
Well, okay, so you didn't understand what he was doing. That's fine. You don't understand most things, like how to be honest. But anyway, are you going to run away today if I mock you?
Dude, you mock me all the time. What's up with that?
I mocked you last time by doing a fake phone call to physics, and you ran away.
No, that was because I was done with it.
Yeah, you literally said, I'm not here to be mocked, and then left the call. But anyway, what are you here for today, right? I am issuing a challenge. The, the challenge prize is for £50,000, which I have. You know, it's all in my savings. It's something that is I'm putting up my own money, and the challenge is very specific. The challenge is to explain a plausible mechanism on a flat, non-rotating Earth for the drift of a swinging pendulum corresponding to your latitude on Earth and turning in the direction corresponding to your northern or southern hemisphere, without claiming it is fake.
Well,
and if you can do that, if you can provide a plausible explanation for how a swinging pendulum drifts amount relating to your latitude on Earth and specifically to the hemisphere that you are on in the direction that it turns, if you can explain and demonstrate that that is the cause on a flat Earth, then you can get the £50,000. But so, what is your response to it? Is your response, I don't believe it's real?
No, my response is prove that it happens like that.
Yeah, I have done already. I've shown you several videos of it.
No, that's not showing me that it's being accurate. Number one, and it's not showing me that
it's very accurate.
Or the southern hemisphere, it doesn't show any of that. It just shows a ball swinging and it knocking over a block. Literally.
And the museums exist all around the world that have focused pendulums happening all of the time. Okay. And this is a well-known phenomenon that is measured, has scientific studies done on it. There's plenty of papers and observations that back up and verify each other, okay? And it absolutely happens. The one experiment that I like to show is the one from the gentleman's physicist.
Why would one from the North Pole or the South Pole where it's super obvious?
Because it's really fucking cold and hard to get to those places, and they don't have tall buildings that would allow you to do it.
You have to go there. You don't got to go there. You can have one of your subscribers or want somebody.
Sure. One of my subscribers is going to go to the North or South Pole, build a building tall enough to accurately make a Foucault's pendulum happen, and then perform the experiment. Yes,
I'm not going to do it.
You don't need to go and do it there because it corresponds to your latitude at every point on Earth that it is ever done. And the one I'd like to show is the gentleman physicist experiment, isn't it?
And Antarctic video. Yeah, I've seen this one.
Yeah.
Show the Antarctic video.
What Antarctic video?
Right. The one that they said that they did where they got little clips of pictures and stuff but no video about it.
What? Yeah, what are you talking about? Of what?
Talking about if you type in Antarctica Foucault pendulum, you'll find out that they did that experiment supposedly, but they couldn't show videos of it. And there is no video to prove it at all.
Yeah. Okay. So let me. If something isn't recorded, does that mean it isn't an actual scientific experiment? Is that how it works? If you don't video record your experiment, it's not science.
But if I were to say that something happens, I'm going to have to record an experiment in order to prove it, right?
No, you absolutely don't have to video record your experiment to prove it. You do the experiment, you publish the paper, and if people doubt you, they can repeat the experiment.
That's something a lot of flat earthers have done in the past. Like, say, for Blue's Cavendish, like they didn't have video cameras and whatever back then into the day, so they just had the data to go by and record all the data, and that's what you go by. So you don't have to have video.
It's an easy cop out for them. Oh, you didn't video it. Oh, well, it can't be real then, because don't expect them to read through a properly presented paper. You know, they want they're the YouTube generation. They want the 5-minute YouTube video.
And then they can put it on there. And then they can put it on there. And then they can put it on the YouTube channel and mock it and clip it and cherry pick and all that.
Yeah, you can't do that with a scientific paper or anything. You know, just a report on what you did. Unless
it's like the break the wand one, like Riley did.
When you can just you can read something with zero comprehension and then just lie about it. Yeah.
And of course, use completely the wrong set of tools.
Yes.
Yeah, let's make a Cavendish. How's it work?
Oh dear.
What's the torsion wire? We'll just use a bit of string.
Torsion? What do you want torsion wire and the torsion balance for? How ridiculous.
Yeah. What on earth did you use a torsion wire in your experiment, Blue? That's silly.
Oh, I don't know. It just something came over me.
Riley can't even use a tool for measuring density to do a bloody experiment on changing the density of the water with an egg.
Hey, you got one thing right in that video. If you watch that one, and he holds it up in his hand and goes, "This is an egg."
This is an egg.
Well, that's true.
Yeah,
That was correct.
yeah.
Looked
He
like
was
a
on a
chicken
roll at that point.
He should have stopped there.
Yeah.
Yeah.
Bless his heart.
This is a parts per million meter. I haven't got a bloody clue what this does.
Yeah, it's got. Yeah.
Yeah. Whoever told him what to do for that whole thing obviously had half an idea. He didn't know what he was doing.
I remember him wanted me to come on to Nathan Oakley's a while back when we were talking about hydrometers. I said, no, sorry, I haven't got a microphone. Well, I didn't have one back then.
No.
Imagine me being on Nathan Oakley's show with him. I would have got muted in the first few seconds.
Yeah. Would have been fun if somebody had put some sugar in the water.
Yeah.
Well, we got
You can't do that with a parts per million meter.
we got Casual Space Matt to do the experiment again, but he hasn't done it again yet.
No, funny that, no.
Hmm.
Yeah. But yeah, that was the point, Alan. Whoever Riley didn't come up with that experiment presentation, whatever you want to call it. Somebody else fed that to him.
They had to. He wouldn't. He's not smart enough to come up with something like that.
Yeah, but using the parts per million counter basically relies on electrical resistance, and that's why he had to add salt to the water, and not sugar or sand or anything like that. It had to be salt because that's the only way it would work. And he didn't bloody know that. He hadn't the faintest. Like he said, "Oh, I don't know what this. It could be anything. Could be unicorn farts." He hadn't got a clue what he was doing. Whereas anybody, whoever else looked. All of us who watched the video said, well, hang on a minute, you're measuring density. Why aren't you using a hydrometer? And he wouldn't know what a hydrometer is. Coughing is a joke.
Yeah.
To falsify what you have done.
No,
That's how it works. Science, there is nothing about science that requires you to videotape what you are doing. However, the gentleman physicist did. And the gentleman physicist came to within 0.4% accuracy. That is very accurate.
That's not accurate at all.
Oh, sorry, 0.4% isn't accurate.
Okay, well, 0.4% of a dime would be like very small. You'd be right. That'd be accurate. But now if you go 0.4%,
I guarantee if you got a bunch of dimes.
That's like the thing that I think I heard it off Bob one time. Something about point 0.999999. Is that one or something?
Oh right, well,
You know that,
yeah, not quite.
You know that
but
analogy
close.
of how that goes? For a
what
full
this-
for a whole number.
What this numbnuts doesn't understand is that 0.4% is an accuracy. I mean, it doesn't matter whether it's something large or something small. It's still the same accuracy.
It's still 0.4%.
Yeah, exactly. He thinks that 0.4% of a dime is only a small bit, right? But 0.4% of 100 tons is, is a bigger quantity, but it's still 0.4%.
Right.
And measured all of them, right? Between all the dimes that you measured, there would be more than a 0.4% difference in the actual weight of all of those dimes. Every single measurement on Earth, every single measurement ever taken has a margin of error. All measurements have a margin of error because it's literally impossible to be 100% accurate. Margin of error is something that is in science.
For the world, you better be 0.0001 in order at least. If you
Why? Why? Please give me a citation that says on Earth experiments measuring the rotation must come to within 0.0001%. Please show me where it says that.
Well, there is no rule book on that.
Oh right, so you're just making shit up then, are you?
How many miles is 0.04% of 25,000? Just on one.
What's that, Al?
Sounds like a typical case of moving the goalposts. You do an experiment that gets a result that's really close, like Blue's lovely Cavendish setup. Well, yeah, just move the goalposts over a bit further so it's not quite accurate enough to be accurate.
Roughly how many runs did you do, Blue, on your Cavendish to get your to figure out G?
I think the total's about 40, 48, something like that. Not counting all of the, experimental stuff when I was, just playing around with it. Hell, I ran the thing hundreds of times, I'm sure, but actual test, I ran at least 48 of them.
And I haven't got all the data here in front of me. The range of the lowest and highest numbers. You got it pretty. I know you got it pretty close to the average.
No, it's pretty tight. I can pull it up and we can take a look at it.
Yeah.
But I don't have the number off the top of my head. But
nah.
No, the data was very well clustered right around that 6.67 times 10 to the minus 11th number.
Yeah.
Well, that speaks to the simply to the repeatability of the test.
Yeah.
Right?
Yeah.
Well, like if the range was completely, like, I don't know a number, but say if you had a range of 5 and it went down to 2 and then jumped up to 9, like a long way away from your initial number, something would be wrong then, wouldn't it? With the experiment, or if you'd after you've done multiple.
The wider the deviation, the standard deviation, the larger that is, the less confidence you have in any particular reading.
Yeah.
It's around 0.5 thousand. What's your mathematician?
0.04%. It was 1.4 degrees, so it was about 80 miles.
80?
Yeah, about 80 miles.
Yeah, if that's right, that's still a huge.
Yeah, 0.4%. That's pretty damn accurate. However, if you'd done that experiment anywhere on Earth, every single time you would come to within 0.4% of your latitude. That would mean that your margin of error for that experiment is 0.4%. And if you can get to within that margin of error of 0.4%, it means your experiment shows that to within a margin of error of 0.4%, you can accurately calculate your latitude on Earth using nothing but a swinging bob on a bit of string. And this is a very lo-fi experiment with a very inaccurate recording method. Every single Foucault's pendulum that exists in a museum, right? Every single Foucault's pendulum that exists in the museum has an exact period of rotation. And every single one of them that are in museums that are going constantly give an exact location to, and I've checked this, within 0.02%. Every single time. All right? There is no Foucault's pendulum experiments that I have seen that are more inaccurate than the one done by the gentleman physicist. They are all more accurate. And the fact that it happens every single time, it always corresponds to your latitude, and it always goes clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Always, every single time. There is an explanation and the mechanism behind why that happens on a rotating globe. If you want to attempt the...
That's one of the arguments that I keep bringing up with a lot of the flurfers when whether to do with that rotation in the northern and southern, and with the sun's right. Gary's trying. I think we were talking to Gary on one of the. I think it was on Jose's there one morning, wasn't it? I think it was talking about that. I think not Farmer. You weren't there, Farmer. I don't know. I think Dean was there, Stingray, and we're trying to get Gary to explain why the sun rises south of east and sets south of west in our summer, and he's saying it's because Capricorn's north or something, or it's east. And I'm going, yeah, it's east of me, but it's not directly east. It's northeast of me in my direction.
Yeah.
He completely bamboozled me with that one. I couldn't work out what he was going on about.
Because he didn't know either.
Oh, they're making it up because the Earth's not flat.
The challenge, you need to give me a plausible mechanism as to behind why, to within a margin of error of 0.4%, a swinging pendulum can calculate your latitude on Earth.
Well, first let's do this. How about if a pendulum is it a pendulum that's rotating, or is it the Earth underneath it?
The Earth is rotating independently to the straight line swinging path of the swinging bob.
How if it's connected to the Earth?
It's not connected to the Earth.
It's on a stand that is connected to the Earth. Yes, it is.
Yeah, but it is swinging. The swinging of it, the path of motion, isn't connected to the Earth. Once it is swinging, once it is swinging, it will maintain its momentum, its position in 3D space, because that's what happens when you have a freely swinging object in physics. It maintains its position. It's the function of how a mechanical gyroscope works, is because when something is moving in that way, it can maintain its position in 3D space, and that's what it does, because it is swinging in relation to the axis of the Earth's rotation, and it is gravity is pulling it down, and there is an opposite force with the string keeping it in a arc due to inertia. That is exactly why it happens.
Okay, but now, so if I go into a cave, a big tall cave, and I put a string attached to the top, and I put the pendulum in there,
Yeah.
is it not attached to the Earth?
It's attached to a pivot point which allows it to swing freely in 3D space.
But it's attached to the Earth.
Yeah, but did you stroke out when I spoke then? It is attached to a pivot point which allows it to rotate freely in 3D space. Do you understand the words that are coming out of my mouth?
Well, I think I do. I'm just being real clear about this. So now, if something's not attached to Earth, it should see the rotation of Earth underneath it, then, right?
Depends what it is, and how it is being held above Earth.
Hot air balloon, helicopter, any of those.
Well, they use the atmosphere which rotates with the Earth, so no, the Earth wouldn't rotate underneath them.
So the atmosphere rotates with the Earth, right?
Yes, absolutely, yeah.
Okay, so if the atmosphere rotates with the Earth, then there should be a wind guiding that pendulum, right?
No, it's rotating with the Earth. That means relative to the surface of the Earth, there is no wind, because there is no difference in speed between the atmosphere and the surface of the
And
Earth.
they've done it in
Wind
the
is a
building as
difference
well,
between
so
the
where's the wind
speed
come
of the
from?
atmosphere and the surface of the Earth, which happens due to pressure differences. The atmosphere rotating with the Earth is the thing that will cause there to be no wind.
Okay. So
Your ignorance of physics is not an argument against it, just so you know.
When the dude jumped from the highest highest skydive in the world, how come there was no wind, or you're supposed to be going about 60 miles or 60,000 miles an hour?
There was quite a lot of wind. You can hear it on the microphone.
No, like he literally was not getting blown out of his thing. I'm talking about 60,000 miles per hour worth of wind, right?
No, there wouldn't be a 60,000 miles an hour wind. That's not how it works. I just explained that. Again, did you stroke out whilst I was speaking?
Well, no, look.
The atmosphere rotates with the Earth. If you're in something, the atmosphere that is making you float because of buoyancy, then you are not going to feel a wind, because you will also be rotating the same speed as the Earth. Does that make sense? No, of course it doesn't. You're a moron.
Well, I mean, if the Earth is rotating with the right?
What? Sorry?
Rotating with the air is rotating with the Earth.
Yeah.
Then the Foucault pendulum could not work.
No, that's wrong. The Foucault's pendulum is attached to a pivot point, which allows it to maintain its position in 3D space.
Not separate from the Earth.
Pivot point.
Yeah, not separate.
Pivot point.
You can repeat it all
This
day.
allows you to maintain your position in 3D space independently to the rotation of the Earth.
No, a helicopter would do that.
No, a helicopter is not attached to the Earth via a pivot point.
That's right. because the Earth should rotate
Is
underneath.
the helicopter attached to the Earth via a pivot point? Yes or no?
That's why it would be better.
Is the helicopter attached to the Earth via a pivot point? Yes or no?
No, that's why it'd be better.
Right, and is the helicopter using the atmosphere which rotates with the Earth for lift? Yes or no?
It's using the air.
Yes or no?
Air.
Atmosphere, yes.
Atmosphere and air are different.
No, they're not. The air is the atmosphere.
Atmosphere and air.
Towards the bottom of the
Yes,
two
exactly. The
separate- they're
atmosphere
two
is more
separate
dense
things.
and less dense as it goes up. Absolutely, 100%. Is the helicopter using the atmosphere to maintain its lift? Yes or no?
using air.
Atmosphere, yes.
No, the air.
Okay, right?
No, it's using the air.
Is the pendulum using the atmosphere to maintain its lift? Yes or no?
No, of course not.
Is the pendulum using a pivot point which allows you to maintain your position in 3D space? Yes or no?
No, because it's not maintaining position. It's spinning with the
Oh, wait, sorry. So the pendulum isn't using a pivot point. Is that what you're claiming?
No, I'm saying that if it
Well, then listen to the question. Is the pendulum using a pivot point which allows it to maintain its position in 3D space? Yes or no?
it doesn't allow it to maintain
That's
its
exactly
position.
what a pivot point does.
It does not. Not when it's
Okay. If you are arguing with physicists and everyone that does science and maths and understands physics, and you don't understand maths and physics and are not a physicist, then you are not arguing, you are just wrong. According to all physicists, all engineers, all mathematicians, anyone who studies physics knows that a pivot point will allow something that is freely swinging underneath it to maintain its position in 3D space, because that's what physics says will happen. So,
Okay, well,
your ignorance of physics is not a fucking argument against it.
I'm an idiot, so what I do
Yes,
is
you
I-
are correct.
Biggest
Fine, so I
diggers,
take a
face
microwave
meat palm.
that spins, and I put a Foucault pendulum on there and see if it spins with it. See,
Yeah, it
see
won't.
Who's right? See who's right.
Yeah, it won't.
It's not independent, dude.
That's exactly what it is. Again, are you arguing with
What's
all the
that,
physicists
Liam? I can't even read. W-B-T. Jeez.
in the world?
Fuck yes, that's what they say. Yes, I am.
Right, so you think you know more about physics than all of the physicists in the world?
No, I think I have eyes, and everybody else has eyes.
Yeah, you're a fucking moron. You think you know more than all the physicists in the world. Right, so anyway, none of that is relevant to the actual challenge. The challenge is to give me a plausible mechanism as to why it happens on the flat Earth. Your misunderstanding of why it happens on the globe Earth is irrelevant to the actual challenge. The challenge is for you to give a plausible mechanism as to why a Foucault's pendulum will show you your latitude to within a margin of error of 0.4% and will rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. For £50,000, you need to give a plausible mechanism and an explanation as to why that happens on a flat, non-rotating Earth. Can you do that?
You gotta show me those videos you're talking about, because I've never seen them.
Again, it's not about your ignorance of physics. It is to why it happens.
I told you before this. I told you go ahead and bring them. You said you'd bring them.
Yeah, again, it happens. It's well-known physical phenomenon. I have shown you a video of it happening, and if you perform the experiment yourself the proper way, you will find out. The burden relies on you to disprove what I am saying, because all of the evidence shows that it does. So the challenge is to explain why it happened. No, shut up. It's not to deny it happens. It's not to claim it fake. The challenge is to say why it happens if the Earth is flat and non-rotating. Why does it happen?
Let's see it happening.
Okay, cool. Here you go. Here's it happening right here.
Okay, I've seen that video.
Yep. So there you go. There you go. There's your evidence. That's all you need. That happens. It matches latitude within 0.4%.
It's not. They even admitted in that video it was fucking way more than 0.04%.
No, it was exactly 0.4%. It was 1.4 degree, which worked out to 0.4%.
1.4 degrees.
Yeah.
Okay. 1.4 degrees is 0.4% of what?
Of 360.
Okay, so if you got, let's see the other videos then.
You want more videos of Foucault's pendulum? Is that what you want?
I want to see the other videos saying where they are, showing that they're along the latitude and longitude.
What's he showing with his phone?
There's plenty of videos of it happening. They haven't done the maths in the videos.
Well, okay. Now, how do you know they're within?
You can go to Curtis. I think his name's Curtis Lane, and he did a one where he actually lied with the Foucault's pendulum as it swung overnight. I'm pretty sure he did the maths on it on that one. But again, if you want more evidence, that is on you. All right. I have shown you that it happens. All right. It is a well-known physical phenomenon.
Aren't the universities freely available, or the places where they've got these Foucault pendulums set up for anyone to go at any opening hours, of course, and just sit there and watch it for a period of time and see how?
Yeah,
you can do that.
And how long would you have to wait for it to be processing around to knock over one of its things? There have to be so many degrees per hour or something, wouldn't it, for whatever size it is?
Just depends on where it is and how they've got it set up. This poor guy, though, you got to feel sorry for him. I mean, this is what happens when the leftover parts of a circumcision survive and learn to talk.
Oh, dear.
Oh, Blue.
He's got such a way with words, hasn't he?
So in other words, the most intelligent part survived.
Yeah. God help us.
I don't care. I don't care if you are saying it doesn't happen. The burden's on you to prove that it doesn't happen when I provided evidence that it does. The challenge is to explain why it happens if the Earth is flat and non-rotating. Can you do that, or is there no reason why it happens?
There is a pivot point that is connected to the Earth. So if the Earth is spinning, it would be spinning with it.
No, pivot points allow you to move independently. That's what a pivot point does.
If they're not attached to the
No,
spinning
a
thing.
pivot point allows you to move independently. That is the purpose of a pivot point.
Okay. So then on a microwave plate, when I put a pivot point above the microwave plate and spin it, it's not going to spin with it?
No. If it was traveling at a constant rate, it would not move because the thing was moving. It wouldn't. It would go with it at the same speed. It would only move once you started to swing it.
No, it's 4 posts are sitting on the microwave tray. You don't think that those 4 posts are going to rotate with pivot point 2?
Right. Where is the bob hanging from?
From the pivot point, make a tent. A 4 posts making a tent.
Right.
or a
Right.
tent.
And then you've got a little bob hanging from your your pivot point on the microwave. Right. And as your microwave table turns, that pivot point will stay complete. That bob will be completely downwards. That's it. As it starts, it will.
That could be still a basic frame that could be done now. It's just on the ground with the pendulum swinging. That wouldn't matter.
As you start in the microwave, it will shake. But after the constant movement keeps going, that bob will be pointed completely downwards. It will not move because the plate is moving.
No, you're right. Now, how come it works on an Earth which is spinning left?
Say again.
How come if you can even spin it faster than the Earth is supposed to be rotating if you scale down, and it's not, and it's going to move with the pivot, and it's still pointing down. Just because it's spinning doesn't mean it's not going to be pointing down.
Huh?
Okay, I don't think you understand what's going on here. The freely moving, swinging bob maintains its position in 3D space, which allows the Earth to rotate independently to the plane of the swing.
But it doesn't.
But it does.
If you put it on a microwave tray or microwave plate, it won't. It will show that the ball.
No, it absolutely would.
Put a mark on the ball side closest.
Right.
to you.
Okay. If that's your claim, go and do it then.
I'll make a video after this.
Okay. Wait. I'm getting one specific.
Is it my turn? Do you see what's on my screen right now? I've been showing this whole time. See
Wait.
that?
Yeah. Okay. We're talking about pendulums here, so.
No, I know, but we're not. We're done with that, right?
No, we're not done with that. That's the purpose here. I've got more evidence to show you. You wanted to see more, so.
Yeah. Let's do that.
Okay, so here we go. This is Curtis Lane. I think that's his name. Curtis Batut, right? He spent a day inside the Natural History Museum. I think it's in Chicago. And throughout the video, he actually shows it moving. You know, he spends the time there with it.
Okay.
Right. And he spends the whole day and night, literally sleeps next to it. You know, there is actually an unedited video on his channel as well.
So all night it swung? Nobody had to swing it?
No, it keeps going because there is magnetic buffers that make it continue to swing in its natural plane.
Well, now wait a minute. That's not a natural swing. Then. That's not,
yeah, it is. Again, it allows it to continue swinging in its natural plane.
It
Do you
also
understand? Do you understand those words? There is no issue. There is no issue. Shut up. There is no issue with the way it swings. It is perfectly valid for a Foucault's pendulum. I don't care about your objections. This is the evidence you asked for.
There's magnets.
Shut up.
Where to
Shut up.
with the magnets.
Shut up.
Ball. Do it without a
The
metal
magnets are irrelevant. Shut up.
Do it without
I
a
said the
metal ball.
magnets are irrelevant. I said shut up. You do not talk about the magnets. They're completely irrelevant.
The magnet
Shut up.
Push it once.
Do as you're told. All right. The magnets are irrelevant. They allow it to continue swinging in its natural plane. And so in this video, he goes over the maths of how long it took to swing and how it compares to his latitude. So you can go back to watch the world turn. And on his channel, he has the unedited video to show that the thing happens completely.
Okay, we can jump that bit and we can go.
Interestingly, this to back up my claim. All right. If you want to do research, listen when I'm talking to you. If you want to do,
Right now, where can you see that football
I am
stadium?
talking. You can't listen if you are also talking. All right. If you want to see,
off.
I'll mute you if you talk again whilst I'm talking. All right. Okay. If you want more evidence of the claim, then it's on you to go and find more evidence. Science does not go to your own personal standards of evidence. I have shown you more than enough evidence to back up my claim that Foucault's pendulums measure the rotation of the Earth by drifting an amount corresponding with the with your latitude, always clockwise in the northern hemisphere, always counterclockwise in the southern hemisphere. The challenge for £50,000 is for you to explain why that happens if the Earth is flat and non-rotating. Can you even attempt the challenge? Please give me an explanation as to why it happens. No bullshit, no fucking complaining about the experiment. Why does it happen? Why does it happen if the Earth is flat and non-rotating?
Okay, ready? I'll show you it on the equator, and we'll see if it moves. How about that?
Again, why does it happen if the Earth is flat and non-rotating? I've asked you more than enough times.
Right? It does not on the equator, right?
No, the plane of rotation to the equator would counter out the fact that the Earth's axis is matching the plane. So at Foucault's pendulum, directly 100% at the equator will not drift.
Okay, let's see that.
Yeah, you can go and find that yourself. I've given you enough evidence.
I'll show you later. But now look. This is
how are you going to show me later? Are you exactly on the equator?
I didn't say I would.
Well, how are you going to do it then?
I'll show you videos.
Jesus.
There's always this reverse burden of proof that I keep hearing with the flurfers. Like you'll tell them something what is, they'll say it's not. Well, that's their burden of proof.
What freaking idiot would build a Foucault pendulum on the equator? I mean, why would you do that? You know it's not going to work.
Yeah. Well, we know it's not going to work.
Yeah.
Same kind of idiot that would try and build one at the North Pole, right?
Yeah.
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 Exactly.
Yeah.
right in the dead center of axis.
Yeah.
Yeah, they actually say stupid shit like that. Why isn't there one at the North Pole?
Yeah.
I didn't get to watch this whole this one, so we'll jump it.
No, I didn't bother with this one, I have to admit.
We'll do a jump.
Where there's a football field then?
How about a city? That right now it's over a city.
Yeah, show me where would the football field be?
Well, that's right. Where would it be? It'd be too small to point out.
Well, no, show me where it would be, and we'll zoom in and have a look.
Well, it would be inside one of the major cities.
Yeah, show me exactly where. Show me exactly where. Right, and then send me a high-def version of the pic, and we'll zoom in and have a look.
Well, look right there. There's high.
Yeah, again, I see snow. All right, you are not saying right. What you need to do here is go. This is where we should be able to see a football field. We can't see it. Instead of just showing random images of the Earth and going, "Where's the football field?" like a fucking moron. Show me where there should be a football field. Take a screenshot of it. Make sure it's high def and send it to me, and we will zoom in live here and see if we can see at least the outline or anything of the football field. All right.
Now I'll show you a football field from 2,000 feet high. Just 2,000 feet, not even a mile. Not even a mile. Let's go with that.
And do you have a high def picture that you can send me?
It's a picture without zoom.
And it's relative to human eyes, is it?
Well, I mean, if it's not using zoom, that's what your camera sees. That's what you see.
No, that's not how cameras work.
If I take a picture.
Are you saying the default setting of every camera is exactly the same as human eyes?
Well, there's no exact same of human eyes because there's different.
Fuck me, you're stupid.
Do you think that people don't have stigmatisms and shit?
Oh.
Is that what you're saying?
Sorry, I'm just laughing at your stupidity and the chat. Anyway, so yeah, show me a high def picture that's equivalent to human eyesight.
That's a good point, Biggest Doggers. Flat earthers with their technology, with devices like laptops or computers, you can always tell which one's a bit illiterate in that way with technology. Using his mobile phone to take a using it as a video for his little iPad thing, when he could be doing it on the iPad.
And that then point out where the football field should be, and then let's have a look if we can make out at least the outline or shape of it.
Do you not think that what we were just seeing that whole time on my screen, the whole time, the ISS live feed, do you not think that that's what they see out their window with their eyes?
Again, I don't know where it was. If you show me somewhere that's supposed to be a
Anywhere.
you know, where we're supposed to see an actual football field, and then send me a high def picture of it that matches human eyes from that height, we can zoom in and have a look. How about that? All right.
Wherever they're filming over a city, you should see it. If it's got a football field there, he doesn't. Never. You'll never see one. How about that? You'll never ever see one.
This is your claim. Show me an exact image of where it should be then, because I have specifically met the burden of my claim. Your claim here is that you cannot see at all anything like the shape or outline of a football field from the height the ISS is with a camera that matches the human eyes. All right. So show me exactly a shot of a place where we should be able to see a football field, where there would be one in the field of view, and we'll zoom in and have a look and see what we can make out.
There is no football field visible from the ISS ever, and you can't show me one that there is.
No, it's your claim. You need to specifically show me a point where it should be visible, and we can test that claim. Go on then, over to you. All right, I'll put your screen up, all right? You've got 5 minutes. Show us where we should see a football field. Show us a picture that in that picture has a football field in it, right?
Okay.
And we can zoom in and have a look. Go on then,
Right.
over to you.
Right. Here's my 5 minutes. Boom. You see that? You see that? How much of that screen is taken up by a football field?
Is that a football field? It looks like quite a lot.
Well, there's a football field in there.
Okay. Oh, you mean American, like fake football? Right. Okay. Wonder why it was round.
Yeah, fake football.
Pigskin football, yeah.
Yeah, that's
Rounders.
Yeah, you can quite clearly see it there. How high is that camera?
1,000.
Oh no.
Right. Okay, so I can see it at 1,000 feet. That's for sure.
Of course, but now if you double that distance, it's going to be half that size.
That's not how angular resolution works now.
No, it's not how angular resolution works. It's how reality works. If you
Yeah, angular resolution is reality.
Really?
Yeah.
At 1,000 feet, it's not taking up any more than maybe.
Well, it's, that picture is clearly not resembling human eyes, is it?
Yes.
So we don't even know if that's a zoomed in
With human eyes,
photograph
or is
what
it a
it
camera
is.
that's zoomed in?
No,
Yeah.
exactly.
Zoom.
So that's without zoom at 1,000 feet.
Yep.
What camera?
The camera of the person that wrote the article. It's a
He doesn't know.
Yeah. What
doesn't know
camera
that.
is it?
I don't know what kind of camera it was.
Why are you not bringing the specifics for your evidence?
Yeah,
Well,
it's
What's
just a picture.
what evidence do you have that is a
Just
zero
an
zoom
image.
level?
Just an
When
image
you
of
look
it.
through any camera, the lens, without having a digital camera, any camera, the lens is going to show you this non-zoom anything. You can
Yeah.
look
So you
through-
think looking through a lens is exactly the same as looking with your eyes?
when I take a picture of what I see exactly with my eyes? Yes.
Yeah. No, that's not how cameras work.
Field of view
So-
for a
so what,
camera.
you
Is a
have
field
two
of
here?
view like our field of view is about what 120 or something, isn't it? Is that about right?
Ish, I think. Yeah, something like that.
What's a camera's field of view?
Yeah, but not only that, all cameras have lenses,
Mm.
and those lenses are different to the lenses in our eyes. You never see exactly if you use a Mark 1 eyeball and then look at exactly the same view through a camera or anything like that, it will always look different. Always.
I wonder if Alan knows anything about this. What do you reckon?
Yeah, sorry, I was trying to talk and I was muted, wasn't I?
Well, that's
Alan,
okay.
you were muted.
Alan, you're muted, Alan.
Yeah, you're muted, Alan.
I'm not muted now, though, am I? For God's
No,
sake,
you're not
tell
muted
me.
now, but you were. Just in
Yeah,
case you
you're
missed it.
muted now, Alan.
Yeah, I know. Anyway, I hate it when people misuse the term zoom.
There.
You only zoom. Right. If I have a lens with if I have a 600mm focal length lens that is only 600mm, it has no zoom.
Correct.
Zoom is 1. My 150 to 600mm lens has a zoom ratio of 4. It has twice the focal length, so twice the magnification of my 28 to 300mm zoom that has a zoom ratio of just over 10.
Yeah.
So talking about zoom like this is complete and utter wrongness.
Hmm.
And
Okay.
lots of people do.
Well, we hear a lot of arguments from the flurfers when they're talking about optics, and they just completely do not understand how optics work, whether it be cameras or even with your own eyes, especially for angular resolution and field of view and those sort of things.
Yeah, you know, I've almost given up on it because it just like
What are you saying?
seems like I'm wasting my breath talking to them.
Sure.
You look through the lens of a camera, you're not seeing what your eyes would see. You're seeing what the lens of the camera sees. So anyway, you're supposed to be showing us a shot with a football field in from the ISS, high def, above a city,
not from the ISS, no.
And then we can see in that if we can make out where the football field would be. Because it's your claim.
I don't think they have a camera on the ISS that will be capable
You've lost the
of
challenge.
doing that.
Well, I have seen images from the ISS of the Earth, like the resolution and the where, as you could say, zoomed in, I suppose, like closer to the Earth. But you're not seeing anything like a football field or anything. You can see a little bit of the terrain and maybe a little bit of that when there's no cloud. Maybe the ocean.
Well, you wouldn't even see train tracks or anything because they might be long but they're narrow.
You're supposed to be able to see the Great Wall of China.
Well, yeah, you're supposed to be, but remember, it's only about 100 feet wide. So no, you can't see it. It might be 1,000 miles long, but it's not very wide.
Yeah.
You would need optical magnification to be able to see something like that.
Yeah.
As far as I'm aware, I don't think there is a single camera on the ISS that has a focal length and sensor resolution that would resolve something the size of a football pitch.
Yeah.
It's more the diameter of the optics that's the limiting factor here, because of course the resolution criterion, Rayleigh criterion, for something that can be resolved is 1.22 times the wavelength of the light divided by the diameter of the optics. That's an approximation. That really gives you the sine of the angle of the resolution, but because it's such a small angle, the sine of the angle is approximately the angle itself anyway. So if you calculate that angle and then use inverse tangent with known distance you're above the Earth, you should be able to calculate the size of something that you can resolve. Has this flat earther done this? No. Like, the argument should be that you should be able to calculate, given the diameter of the optics and the height you are above the Earth, what size objects you should be able to resolve. He should really do that before he makes any claim as to what you should or shouldn't be able to see.
Yeah. And I think you'll find that you can resolve something the size of a football pitch from the ISS, but you'd want something with about 100 millimeters of aperture.
I've never done the calculations, so.
I know I can resolve the ISS from the surface using a 95 millimeter aperture.
Quit. Yeah, he's ready to quit.
Yeah, did he?
Oh, beautiful. Absolutely beautiful.
Got him on the image.
Yeah, you're right, Mandelbrot set. A Foucault's pendulum does not.
So I don't think he brings anyone else into it again, or any other flurfers.
Don't know, couldn't tell you.
Yeah. Oh well, we'll leave it there for that one. It doesn't look like he comes back. Not going by. It looks like he just brings some other people in. Okay. Wow.
Well, that's a great debate, wasn't it?
Well, there is other flurfers out there that give you a little bit more content for their arguments.
Yeah, no, that guy's just he ain't with it.
Like at least with Gary, you get some derp.
Yeah, to a point.
Pure derp.
Oh, he comes back, and the other guys make fun of him too. Oh, he comes back, did he? Well, it'll be just more of the same. Alright, okay, well we better do something else now. We're on up to 2.5 hours on our timer.
Are we really?
Yeah, already, yeah.
Blimey.
Yeah.
Okay.
First time?
We've been here 2.5 hours already. Have you still got coffee or tea left in your thermos, Farmer?
I think I've just yeah, I'm just there ain't much left in there. I've got about a mug and a third.
Yeah, well, I have to walk. I have to walk down to your kitchen all the time to grab another one.
That's the only problem. We're sort of using a spare bedroom as like your office come what have you. It's like, I've got to go all the way downstairs to the kitchen to make a cup of tea.
Yeah, well, I can just walk into my kitchen, so that's where I'll be for a second.
Okay, fair enough. Yeah, I can't do that. I certainly haven't got room to settle this up in the lounge.
Well, we've got two things. We can either do a small physics problem or we can do a very hard quiz.
Oh, that's right. Yes, you said that was a toughie, didn't you?
Yeah, I do have a very hard quiz. But I've also got a little puzzle, which I think Farmer's Boy and Blue will be excused from because they've already seen it.
Oh, yeah. Yeah, fair enough. Biggest doggers. I did sort of bring the tea making kit with me. I mean, I got a thermos. I'm not dragging the bloody kettle and all the makings up here as well. Blimey. Stop that.
Now,
Yeah, I remember this one.
Yeah,
yes,
is Terry sharing that out to the peanuts or?
Yes.
Yes,
Should be, I think.
he is.
Okay.
If you're sharing it should go out straight out.
Yeah, it's gone out.
It is good. All right, so we've got a little physics conundrum here. Blue knows what I'm talking about, and so does Farmer's Boy because he's seen this already.
Mm-hmm.
But here we've got a bridge that's a water bridge. So, of course, designers of bridges have to account for the extra load of whatever's travelling across the bridge. Like if you've got a train bridge or a car bridge, you've got to take into account the weight of the traffic that's on the bridge. There's obviously a maximum load limit that the bridge can support. So here we've got a water bridge, and in this water bridge, let's say there's 10,000 tonnes of water flowing across the bridge span there. So what do we have to do? Is there anything we have to do to take into account if a 1,000 tonne ship now crosses that water bridge? How will this affect the load bearing capacity of the bridge? Any peanuts like to hazard a guess or a reasoned answer as to how this will affect the load on the bridge?
Would it be anything to do with the cubic meters of water that's actually over the bridge as well? The weight. If you got
Well, you've got a certain amount of water that is constantly across the bridge, right?
Yeah, that's what I was saying.
Yeah, so that will stay the same. So if there's 10,000 tonnes of water there without the ship on there, and then you have the ship pass through, will that add to, reduce, or stay the same, the load on the bridge?
And knowing the way structural engineers work, if the weight's 10,000 tonnes, that's been designed to take 15. At least.
So do you know what I'm talking about there, Terry? Or?
Yep.
Yeah, is the boat adding weight to the bridge or not? That's the question.
That's the question. Yeah.
Yeah.
I'd say yes.
Can you reason that out for us, Terry? What's your reasoning for that?
Because I've got that other little diagram with the scales with the beaker of water on each side with the little ball in it that's hanging off a string. On one side, you have to guess which side of the pendulum, which side of the scale the beaker's going to fall once you cut the string off on one part of it.
Okay, so we've got a couple of answers out in the peanuts. If I can, I have trouble scrolling back. Sometimes it doesn't want to scroll back.
I've
Yeah, I
noticed
know
it
mine
started
doesn't do it either.
Yeah.
Mm.
If you persist, it does it. So we've got Carl Edwards. It says it remains the same weight. Okay. And we've got Dora, who says there will be no difference since it will displace the volume of water to elsewhere. The increase in water level is negligible over the canal its length. So that's her answer. What do you think of those answers, Terry?
Just displace its own volume.
So think of it in terms of why does a boat float? And how low in the water will the boat go? So the trick is, of course, that the boat floats because it displaces its own weight in water. So however much the boat is of the boat is below the water, that's the water that it displaced is equal to the weight of the boat. So where will that displaced water go? Well, it won't stay in the canal. It will be spread out over the entire river. And so the amount of water that's in the canal, in the bridge section, will actually be reduced when the boat goes across it because it's displacing water. But the amount of water that it's displacing is equal to the weight of the boat itself. So the actual weight on the bridge won't change one single bit. It won't make any difference what the weight of the boat is because it'll push away the water, which will flow out of the bridge section into the rest of the canal. So no, the engineers don't have to take into account the weight of the ship. Does that make sense?
Yeah.
Yeah. Okay. All right. So now that we've done that one, how about we get to a hard quiz, hey?
Yeah. Oh, hello. Yeah.
Yeah. Hard quiz 73. So I've made this one reasonably hard.
Good dear.
Okay. So are your brains not functioning yet now?
What was the question?
Fleetwood Mac.
Fleetwood Mac. Let me get the internal chat up if I can. I might have to stop sharing this for a moment. All right, just to
I was
get
enjoying that.
You were.
just to get the internal
I
chat
was.
up. All right.
Don't get many into the pound, do you?
All right. Won't be long.
That, ladies and gentlemen, is why they're called fun bags.
Well, I can put the screenshot back up for the peanuts.
Oh,
No, it's all right. There you go.
No, I mean I could have. I could have put the image up for him.
Blimey. Just remember the camera's on, yeah.
Okay.
Lordy, lordy.
All right, here we go. Question 1. Okay. One term in a decomposition of this quantity is used to calculate the Reynolds stress. What quantity is it we're talking about?
Never heard of Reynolds.
Yeah? Have you heard of a thing called Reynolds number?
No, never heard of Reynolds.
No?
It does ring
Okay.
a very, very vague and distant bell, but
Reynolds number is to do with when a flow becomes turbulent, as opposed to laminar and smooth. Okay, your second clue. The line integral of this quantity around a closed material contour is constant over time, according to Kelvin's circulation theorem. What is this quantity?
I've heard of
I
Kelvin.
think this is all ringing bells from my college days, but it's too long ago.
Oh, I was only last year.
We've got bubes, we've got dizzy, we've got angstroms, we've got mesmerizing, handful.
Yeah, that's got nothing to do with the questions.
No. All right. The profile of this quantity develops during flow due to the fact that it is zero along certain boundaries when assuming the no slip condition. What is this quantity?
I should know this.
Velocity's not a quantity.
Isn't it?
I thought velocity was to do with speed and...
But is it a quantity? Of course it is.
Okay.
Big Blue's got the right answer.
Has he? Oh, Blue.
Yeah.
Aren't we putting them into everyone anymore?
Mate, we haven't been doing that in ages.
And there's a peanut. There's a peanut that's got the right answer too. There's a couple of peanuts that have got the right answer.
Ah, okay.
I'll give you the rest of the clues. 1/2 density times this quantity squared is equal to dynamic pressure. This quantity times length scale over kinematic velocity gives the Reynolds number. The product of cross-sectional area and this quantity gives the volumetric flow rate.
Yes, of course.
Yeah.
I know what volumetric flow rate is.
Name this quantity that represents how fast particles in a fluid are flowing and is measured in meters per second. You should be able to get the answer from that.
I reckon it's
And
from that
a
answer
couple of
that it
people-
starts with this letter. Save me typing it all out.
Haven't typed it in.
You haven't typed it yet.
I'm trying to
Is
type
it taking
it.
you that long to type one letter, Terry? Oh, come on, Terry, I'm waiting.
Yeah, so am I.
Ah.
It's too dark here. Oh, there it is. I kept on pressing the one next to it.
Yeah, that's right. And
That's
you were right, Terry, when you said velocity. Except you got the wrong thing when you said velocity isn't a quantity. It is, and it is. The answer is velocity.
When
right?
when you have
Correct.
it in when you
Well
have it in,
done.
when you have it in context, I understood it.
Yeah. So Biggest, Doggus, and I think Judy got the correct answer out there, and Blue got the correct answer in the internal chat.
Right.
Velocity is the correct answer. Yeah.
Okay.
Okay, question 2. This process can be measured through a namesake bump in the power spectra of the CMBR, cosmic microwave background radiation. What process is it?
No.
I wish I'd have went to school to learn more.
Wish I could remember more.
Yes, Wolfie, I am special. I tell the flurfers that one.
A transition in a substance that has undergone this process produces a spectral line used in PNLFs to measure distances.
So it's a particular process.
Yeah, what is this process? No, Carl, it's not the expansion of the universe.
Blimey, didn't expect to see that as a possible answer.
The end of the Gunn-Peterson trough in quasar spectra marks the beginning of an era named for this process that followed the recombination era. Some people might know the answer now.
Some might.
We do have a correct answer out in the peanuts. The degree to which this process occurs at thermal equilibrium is given as a function of temperature by the Saha equation. This process takes 13.6 electron volts of energy for a ground state hydrogen atom. No. Wrong copied answer, Farmer's Boy.
I'm not looking at the side chat.
Yeah,
okay.
I was just going to say.
I don't look at the side chat when I'm doing this because.
Yeah, well, I was going to do that.
Yeah.
Because somebody wrote
Gases that undergo this process become plasmas.
But it's not that. Oh.
So it's not that one either, then, Paul.
No,
Okay.
That's what Farmer's Boy wrote.
Did he?
Yeah, with that clue as well, that's what I'd go for.
Okay.
Yeah.
Okay.
I don't know then.
Name this process in which an atom or molecule gains a net charge.
Net charge. Is that the last clue?
Yeah. That is, yes.
Okay.
And Blue's got it.
No, it's too long ago.
Well
I can't remember it.
Yeah.
Gains a net charge. If it's that last word, I wouldn't have guessed that word.
Well done to Clive Wells, who got it first out in the peanuts, and Blue, who got it in the internal chat. It is ionisation.
Oh, ionisation. Oh, okay, I thought you meant recombination.
Yeah.
You wouldn't have guessed
Okay.
ionisation, Farmer?
Question 3. Ken Thompson used this process to create a running example of an exploit in his paper, Reflections on Trusting Trust. What is this process?
Huh?
Huh?
Huh? Who's Ken Thompson, Farmer?
Don't know.
In this process, use-def chains can be created to enforce SSA form, which in this process facilitates copy propagation and constant propagation. What is this process? You'd be right, Dora. Ken Thompson is a computer scientist. You're onto a clever track.
Wolfie's waiting for the picture.
No, John Stock, it's not sex. This process typically makes internal use of an intermediate representation. What is this process? Not Ken Wheeler, not Magnetic Festa, no.
Good old Uncle Fester.
This process is visualized using T-diagrams, which can be used to demonstrate bootstrapping.
No idea.
No?
Well, if this is
Another quick clue
computing, no, not a clue.
Yeah. During this process, the execution speed of loops can be increased by unrolling them.
We'll probably know what the answer is, Farmer,
Yeah,
Oh, you will.
but not the question leading up to it by the sound of it so far.
Yeah.
Oh, Java.
Programs that perform this process, such as GCC and Java-C, are often contrasted with interpreters.
Come on, Farmer, that
So
should
it's
give
not
it
an
away now.
interpreted language. If it's not an interpreted language, it is a... Oh, the peanuts are onto it now. Name this process the conversion of source code into machine code executable And the correct answer, which Dora gave first, I believe, out there, was compiling. Compiling a
Whatever
program.
that is.
Whatever that is.
Yeah, whatever that
I
is.
thought I'd throw one in there. I thought I'd throw one in there for the computer people for a change.
Yeah.
Nerds.
Nerds, yeah.
Yeah.
Computer nerds.
Yep. Compiling.
I'll stick to tanks.
All right. Okay, question 4. A history by John Dickey notes that one of these businesses dictated town plan amendments during a city's so-called sack in the 1958 to 1963 economic miracle. What are these businesses?
Businesses dictating town planning amendments. So you want a business?
I do, yes. Another of these businesses sent nuclear waste to warlords in Bosaso, Somalia. Not malls.
What?
You want some nuclear waste?
With malls.
We've got some.
Yeah.
It's by the bins round the back. Yeah.
No. Another one of these businesses burned garbage in a land of fires that caused cancer in a triangle of death, as reported in the 2006 expose Gomorrah. What are these businesses? They're not brothels. Not car manufacturers, not bakeries. Well, that's kind of right, Farmer's Boy, but that's not all that they did.
Oh right, okay. Christ, I was joking.
The Maxi trial prosecuted one of these businesses that gained power from 19th century lemon exports.
Oh, it's not that one then.
Not piracy? Not hospitals, no. Not pharma companies, no. In America, the original targets of the RICO Act were immigrant affiliates of one of these groups that extorts pizzo protection money and follows the code of silence omerta. What are these businesses? That is correct, Blue. Well done.
Oh, Blue got it.
And correct, Dora. It is the mafia. Yeah. New York's Five
right.
Families, Calabria's, I can't say that word, and Sicily's Cosa Nostra are among what Italian organised crime syndicates? The mafia. Yeah.
Vastly overrated
done.
film.
Yeah. Question 5. For stationary objects, the derivative of one form of this quantity with respect to another form of it is equal to the square root of the 0,0 term of the metric tensor. What is this quantity?
No.
Displacements named after this quantity lie above or below the light cone. Not gravity, pal. Not luminance, Carl. No. The speed of light multiplies changes in this quantity in the definition of a quantity symbolised delta S squared. Not inertia. Not Borg Jesus. Not mass, no. The arc length of a world line gives a form of this quantity that is observer independent. We do have a correct answer out in the peanuts. A phenomenon that affects this quantity causes the transverse Doppler effect. This quantity is plotted on the vertical axis of a Minkowski diagram. Big Blue's got it. And so has Clive Wells out in the peanuts. Well done. The twin paradox arises from an incorrect application of this quantity's dilation. Name this quantity that in special relativity is unified with space. It is, of course, time. Yeah. It's something that the Flurfers have a hard time.
They have a hard time with space, and well, they know what space is and know what time is, but when you say space-time, that confuses them.
Well, that's because we call it the fabric, and then they get confused because they think it's an actual fabric.
Yeah, exactly. That's just what I was going to say, Farmers Boy. Whoever coined that phrase, the fabric of space-time, has got a lot to answer for.
Yes, because you get the likes of SE going, well, come on then, show me the fabric of space-time. Yeah, it's not like a bolt of cloth in your hand. It's not that sort of fabric.
It's just a coordinate system.
Yes. Well, that's not a fabric. Yeah, but oh, never mind.
Yeah.
When they ask me what it's made of, I tell them polyester.
Okay, question 6. Chirping crickets and the sound of helicopter blades open a song by this artist in which the chorus sings, "We said we'd all go down together." Who is the artist?
Oh, you want the artist?
I do. Yeah.
How about that?
That would be correct, Farmer's Boy.
That's one of the best ones he's ever done, and you never hear it played on the radio.
This one must have been too easy because the Peanuts have got it too. Well done, RT96, getting it on the first clue along with Farmer's Boy, but I will give you the rest of the clues for the rest of you anyway. This artist sang that Victor was born the spring of 44 and never saw his father anymore after meeting a down during a tour of the Soviet... A clown during a tour of the Soviet Union. Yeah. Goodnight Saigon and Leningrad appeared on this artist's albums, The Nylon Curtain and Stormfront. That should have given it away. Twyla Tharp choreographed a jukebox musical with the songs of this man, who danced with Christy Brinkley in his music video for Uptown Girl.
Yeah.
This man rhymed Ayatollahs in Iran, Russians in Afghanistan, in a song that strings together Cold War headlines. Named this American singer of We Didn't Start the Fire, and it was, of course, Billy Joel.
The best line in that first song, for me, has always been... Because it's about the Vietnam War, and there's a bit where he says, we came in spastic like tameless horses. We left in plastic as numbered corpses. It's just...
Thank you. Thanks, Dora, for acknowledging that Liam beat Clive to the time question. Well done, Liam.
Yeah, he's... It seems most of the best songs he's done hardly ever get played on the radio. They keep bloody Uptown Girl's got to be the worst song he ever did.
I know.
I know it's personal to him because it's about his then girlfriend Christine Brinkley, but it just God no.
Yeah. Okay, question 7. After Hurricane Katrina, U2 and this band covered "The Saints Are Coming" in the Superdome for charity. Who was the other band?
Yeah, who was the other band?
Yeah.
Blimey, that's a good one.
Yeah. I'm not saying I know, but...
I can't remember at the moment.
Gee, that's a while ago, that Katrina.
A music video for one song by this band ends with their car smoking to a halt in a field, segueing into the next track's music video. No, it's U2 and another band, Carl. You can't give U2 as the answer when it says U2 and this band.
Yes, they appeared with themselves.
They appeared with themselves, yeah.
Come on, we're going to
Not
we're
U3.
going to form a collab. Who with? Well, ourselves, obviously. Oh, okay.
But Big Blue has the right answer.
Oh, okay.
You can't.
Yeah.
I don't know any bands that would have been around back then. Are they still around today?
The bridge, yeah. The bridge in that song includes an announcement that the representatives from California has the floor.
Yeah. Them?
No, that's not
Okay.
right. No.
Because this is going back a few years, isn't it?
Yeah. I was trying to think how far back it
That
goes.
I know that bloody line.
Yeah. This band usually closes out concerts with a song that begins another turning point, a fork stuck in the road.
Oh, this is on the tip of my tongue. Bollocks.
Well, stick it out, show everyone.
No, it's not.
I know that. I know that bloody line as well, but I know the lines from tens of thousands of songs.
Okay. Summer has come and passed. The innocent can never last. Begins a song dedicated to the late father of this band's lead singer, Billy Joe Armstrong. It's those people, says Carl Edwards.
Yeah, go.
Name this punk rock band that included Holiday and Wake Me Up When September Ends on their album American
Punk
Idiot.
rock band.
Yep.
Rock band.
Yeah.
Punk rock band.
Carl Edwards says, I knew it. It is them. That is correct, Farmer's Boy.
I knew I'd remember in the end. So. Not really a group I was into. But...
Have any? Yeah, the Peanuts have finally got it. Stellarium, Celestia, Spooky Bed Hair. Green Day was the correct answer. Yeah.
I probably know one of their songs if I listen to one of their main top hits.
American Idiot.
Yeah. Okay. Question 8. Spectra from these entities follow a broken power law with a threshold between 0.1 and 1 MeV and can be fitted to the band function. What are these things?
Oh, yeah. Fleetwood Mac.
I
don't know. 42.
These entities could be created when expanding shells of pair plasmas cause flash heating of the interstellar medium, according to Mazaros and Rees' relativistic fireball model. What are these things?
Well, that sounds like a cross between Deep Purple and Pink Floyd.
Not brown dwarves.
Oh, bugger.
While looking for covert nuclear weapon tests, the Vela satellites discovered these events in 1967.
Wow.
Bit of a stab in the dark.
No, that's not right.
Okay.
It's a 3-word phrase. I'll give you that clue.
Oh, okay.
These events were first located by Italian-Dutch satellite RepoSat, which observed the afterglow from interactions between their ejector and interstellar gas. What are these things? So, Little Wolf, you're kind of on the right track, but that's not the actual answer. These things produce what your answer produces these things.
Yeah,
Gravity
LS,
waves, Terry.
not LSD.
No. The short kind of these events are created by neutron star mergers, while the longer kind arises from massive star death. Name these extremely energetic beam-like events that release the shortest wavelength of light. Oh, it's going to come down to the picture, isn't it?
Probably.
Okay.
But you want a three? Yeah, it's
Not
three-word
DMT.
answers. The confusing bit.
Yeah. Do you know what they're called?
Pulsar.
No, a pulsar is what produces these things.
It's on the tip of my tongue too, Farmer.
This one ain't. I've
What? I'll give Big Blue the answer. That's correct, Big Blue. That is also the correct answer, John Rapp. Well done. They are gamma ray bursts or gamma ray pulses.
Sure.
Yeah.
I don't know bugger all about that.
Okay. Question 9. A Fabry-Perot interferometer's finesse equals the following pi times the square root of a quantity related to this phenomenon, all over 1 minus that quantity. What is this phenomenon? I'll be extremely surprised if anyone gets the answer from that clue. Maybe Clive might.
There you go. It'd be going good if he does, that's for sure.
Well done, Liam. I didn't see your answer. You're not invisible. It's just hard for me to scroll back in the chat. For some reason, it just wobbles whenever I try to scroll back on it.
What you have to do is actually click on the slider that's on the right-hand side.
Yeah.
If you click on the slider, it works fine. If you just hover over it and scroll up with your wheel, it does the stutter thing, doesn't it? It's only been doing that the last week or two.
Yeah. If I persist with it, it does, but it's a pain in the ass.
Yeah, no, it's a recent thing on YouTube.
Yeah. Okay. Clue 2. If media permeabilities are near mu naught, the energy carried by this phenomenon is equal to the square of the following: n1 minus n2, all over the sum of n1 and n2. That should be n1, not none.
Yeah. Yeah. None.
Yeah.
Come on, put your answer out there, Liam, and then you can say we see it.
Yeah.
The propagation of an evanescent wave parallel to an interface causes a lateral displacement when one type of this phenomenon occurs in the Goose-Hanschen effect. Butt stuff. No.
Butt stuff. Well, that covers a multitude of sins, doesn't it?
It does, yeah. Okay. For an incident wave with wave number k, the wave produced by this phenomenon has a wave number of minus k.
Oh, good afternoon, Dean.
Yeah.
Hi, Dean. Morning.
Morning, he says. It's 3 minutes to 2.
Yeah, morning for us.
Not refraction, John Rapp, no. This phenomenon does not occur at Brewster's angle.
That's Stingray's answer.
It's a bev hump. Ooh.
Not the airy line width, no. What doesn't happen at Brewster's angle?
I don't
Not
know,
diffraction, Dora.
Brewster.
No.
They made the buffalo.
I wonder if Clive got it.
In this phenomenon's diffuse form, the incoming and outgoing angles are not equal. We do have a correct answer out in the Peanuts, and Blue's got the correct answer now too. Well done, Clive Wells and Blue, with getting reflection. Name this phenomenon in which light bounces off an object. It is reflection.
Oh.
Well, we had a refraction from John Rapp, so he was close.
Yeah, close, but no cigar.
Yeah.
Question 10. In the Roman Empire, the primary or secondary forms of this practice were respectively accomplished by building a bustum or an astrinum. What is this practice?
Known to Romans, probably something incredibly lewd.
Oh, what did the Romans ever do for us?
Yeah. Items used to hold the results of this practice lend their name to a Bronze Age Central European culture that was succeeded by the Hallstatt.
Well, that's obviously not the answer I gave then.
Not crucifixion, no.
Crucifixion's a doddle. Get you out in the open air.
I'm Brian, and so is my
My
wife. Not arches, not sleep, not getting drunk, not orgies. In 1969, the earliest known evidence of this practice was discovered at Lake Mungo, Australia, where the presence of ochre pigment suggests its ritualistic performance. Not healthcare, not aqueducts. You're kind of on the right track, Carl Edwards. But that's not the right answer. No, John Stock, it's not wanking.
What?
No, that happened in the masturbatorium.
Yeah, we do have a correct answer out in the Peanuts. This practice became less common with the rise of Christianity due to its incompatibility with the concept of resurrection of the body. That should give it away.
Yeah, that's what I was thinking.
Not tattooing.
I spelt it wrong.
That's right, Terry. There is a single word answer for that.
Yeah.
Yeah.
It starts with a C.
It does, Terry, yeah. And Liam got it first out in the chat. Well done, Liam. He's on fire tonight.
Ah.
Yeah. Carbonised artefacts located in Tumuli have provided evidence of this mortuary practice, which characterised the Urnfield culture.
Oh, yes, a tumulus is a burial mound, isn't it?
Yeah. Name this practice in which bodies are disposed of via combustion. It is cremation.
Yeah, the practice that became less common with Christianity gave it away for me. That one, that section.
Because it's kind of hard to imagine a body being resurrected from ashes, isn't it?
Yeah.
Yeah.
Well, once you've been cremated and put through the grinder, yeah.
Yeah. And that's your quiz for tonight. Well done.
Cool.
Oh, science ones were.
They weren't all really hard. There was a couple of ones in there that were.
Well, the Billy Joel one was a piece of piss, but
oh yeah.
I happen to be a Billy Joel fan, so it was and the Green Day one was annoying because I thought I know those bloody lyrics, and I used to work one of the offices I worked in. One of the project managers there, he was actually the drummer for a very good Green Day like cover band. and the company used to allow them to take sort of days off all over the place because they actually toured all over Europe. I can't remember what they were called, but they were a pretty good Green Day cover band, and he was the drummer, and he'd be forever sitting at the desk. If he was reading something on the screen, he'd be practicing his drumming, sort of air drumming, and yeah. So I'm fairly familiar with Green Day, but I just couldn't place those bloody lyrics. It's so annoying when that happens. I know that song, but yeah, the Billy Joel one.
Thank you.
Okay.
Yeah, it was good for a laugh. Which makes you realise just how much you either didn't know or have forgotten.
Yeah.
Okay, where's that blue one? Oh, that's private, that one. Is level horizontal? Nope. That's private. Any other blues ones that are not private?
Yeah, that level horizontal one is a live stream from last night, and it's still processing. So
Yeah, okay.
I just got it. It's private.
Professor Phil still had. Where are we up to on his?
Oh yes, I don't think we caught up with him yet, have we?
Yeah, I'm trying to remember what number we're on. I can't. He doesn't put a different image on his thumbnail. It's the same. Basically the same. Any peanuts? Oh yeah, I can see which one I'm up to. Going by the little red thing along the bottom. Looks like we're up to number 4, I think. Going by what I've got here. Alright, that's blue out of the way. I've got blues, Oakley and QE curved adjacent nonsense. Get rid of Craig's. Get rid of that. What else have we got? That was a hint to one of them.
Yeah, I know that was.
Oh. Who else was there? I've got to stick to the date too, 27th, so I can look at anything before 23rd, looks like. So anything before the 23rd, after the 23rd.
Arr.
23rd.
Arr.
There she blows.
That was struggling to focus on that, Blue. And you're muted.
Yeah, I thought it was background.
Yeah.
Oh well.
Oh well.
I blurred the background.
I'm not even looking there. I've only got 2. At least need something else. What else is out there? What's Anton's that one? Black hole that's forming stars instead of destroying them? How can a black hole form stars and not destroy them?
Wouldn't that make it a white hole? Come on, you've seen Red Dwarf, you know how it works.
No, I haven't seen Red Dwarf.
White hole spewing time back into space. That's one of the better episodes, huh?
Rings around the sun explain the absence of some types of planets. Early rings around the sun explain why Earth did not become super... I can't read that bit. That's Anton. A lot of Karen videos made by a lot of people lately. Or auditors.
Yeah. There seem to be a lot of them about.
The one with what's his name? He just went over to America. Geez, what's
Irish
his name?
Demon.
That's the one.
Yeah.
He got
Yeah, I think
He
that's-
got stuck in the Atlanta airport for ages. 'Cause I think they might have
Oh, they
got
got a
snowed
snow,
in or the weather.
a snowstorm or something.
Yeah.
Yeah. That's
Who
just
would've-
unlucky, that is.
Who would have thunk that? Leave Australia in the summer, nice weather, and then go over to somewhere else when it's cold and freezing.
Was that? Did you really say who'd have thunk that?
Yeah. Why isn't it hot and warm? Why isn't it hot and warm like it is here when I get there? Something wrong with your weather,
Yes,
Blue?
No, we're having winter up here.
Up where?
Yeah, we are.
You mean down there?
Okay, down in the northern hemisphere, it's winter.
Yeah.
And some people are having more winter than others.
Did we do?
I mean, we're having our usual winter. It's just cold and grey and, you know.
Oh, that's the 22nd.
We had a dusting of snow last night.
I don't think we've had any snow at all this winter. Well, not yet, but we're still in January, so yeah, come March, probably get some.
I didn't think you got any snow where you were, Blue.
Oh yeah, we do.
Oh, you did.
We've already had 3 or 4 snows this season.
Wow. I watched a video of a bloke on one of the American news reports. This guy was driving his snowplow along the freeway, and he's shooting all the stuff over across the other lanes, and caused several cars to get damaged and crashes and everything. The bloke's on report and all that. But whether or not the people get their reimbursement from whoever controls all that or not, it's a different story.
Must be those noses.
Well, he's going to go for drug and alcohol testing. Why would he be shooting all the snow across the other lanes on the freeway as he's driving along?
Yeah, makes using the snowplow rather pointless if you're just going to move it onto the into the other lanes.
Yeah. Bob the Science Guy's been doing selecting a slide rule number 3 specialty slide rules. He likes his slide rules.
Yeah, he does.
I must admit, I haven't been watching them because slide rules.
Yeah.
They tried to teach me how to use one of them at school once, and I said, "But I've got a calculator in my bag." Even my dad doesn't use a slide rule anymore.
It's sort of like using a micrometer, isn't it? Similar, isn't it? Where you got to line up the numbers and something.
Yeah, you've got to line up things.
Yeah.
Professor.
Okay, can we go with 3?
Nobody this day and age uses a slide rule.
No.
Nobody.
I mean,
Okay.
Except for that, yeah.
Have you got?
oh,
Have
they
you
are
got?
good for something. Yeah.
Have you got one at all, Blue? Have you kept one for whatever reason?
I
one
guess
like
Terry's
that.
not watching the screen.
What? I can't see the screen. No, I can't at the moment.
No.
Now I
Makes
can.
a very good
Now I
back
can.
scratcher.
Oh,
Go on,
yeah,
Blue.
so-
Show him
yeah.
what. Show him
Wait,
what it's
wait a
for.
minute. I'll put you onto full screen for me. So. Yeah. And what do you do with it?
Slide rule. What do you do with it? You do this.
Oh, okay.
And if that doesn't reach, you pull that part out.
Oh, I can
Now you
extend.
go.
It's extendable. Right.
Yep.
Now I know. And it's got numbers on it, but you don't know what they mean?
Yeah,
Yeah, they're just numbers.
Right.
Nobody knows what they mean.
No.
that's right, mate.
Have you got any report of the university with your little toy? Have you heard anything or seen anything from
Yeah,
them?
they've been playing with it, learning how to use it. And the new semester starts here in next week, I think. So
Have they got a Facebook or something like that they upload anything to, or their own?
I don't know what
media.
I don't know what their plans are in terms of in terms of that, Terry.
Okay. 'Cause I
There'll
thought-
be some news though here before too long.
I'm thinking of
We'll see how they do.
with modern technology and the way kids are with the media and having all their things like that, for either Facebooks and Snapchats and TikToks or whatever they call it, they'd be posting things somewhere.
Twitter.
Twitter, yeah, one of
Yeah,
them.
Twitter.
Right now the professors are playing with it. They're having fun. And
This is our toy. You'll have to wait your turn.
yeah, they really are. You know, you got a limited amount of time with a class, and they're trying to work out the almost foolproof method, or whatever, so they can say this is what you need to do, and when you need to move the weights and all that sort of thing. So,
Well, they're not going to do it in
I
one
just-
class sitting, like 1 40-minute class session or whatever.
oh no, it'll be an all-day thing when they do it.
Yeah. Yeah. Alan had to drop out. He had visitors.
The mob turned up.
Yeah. What have we got here? What happened to your Halo, Paul?
Oh, I can
It
put it
slipped.
back. Where are we?
Oh, you had a hat on then.
He's cruising, right?
His Halo dropped.
Cruising.
His Halo dropped and was going to choke him.
There we go.
Okay. Paul the Angel.
Yeah.
Did
take
you
your
find?
halo
Did
off
you
and
find
hang-
that
hang
tank
it on the
yet?
bed frame.
Did you find that tank yet, Farmer, or you didn't bother?
I can go and have a quick look if you want.
Well, I was just either wondering if you wanted to show the lid for the one or one that you've got nearly finished, because I remember you did show one a fair while back, but I don't know which
Yeah,
one that
but it doesn't
was.
mean to say I've done anything else with it since.
Oh.
I haven't. Nothing on those two tables has been touched in probably 2 months. I've not been in the mood, and then at some point I'll just go bam, and I'll just.
Well, you know you've got a challenge with what I said to you before. You've got to do a live gluing together of a piece or two.
I can do that. Yeah, we can do that next weekend if you want. I can. We can either do that, or I'll show you how the tracks go together.
Wow.
It might take longer to build it, but it'll be in the same time frame as how long it's taken now anyway. Like if you just show us how to put one piece on it.
Some of it. So I am incredibly good at starting these things.
Yes.
No bloody good at finishing them. The problem is you can put them all together. You can do all the work. You can have all the fancy little details. You can undercoat it. You can spray the colour that you want. That's easy. It's weathering it, making it look like the real thing, and it's scuffed and dirty and dusty and got stains on it. And all that's the bit that I'm having trouble with, because it's been a long time since.
You mean like the ones that put together things and they leave it all nice and shiny and clean and like it just rolled off the factory floor? Nah.
Yeah, when you come to tanks, that doesn't look right. It doesn't take long at all, and they look used. Even once they've if they've been out on an exercise and come back and steam cleaned them, they still dents, scuffs.
Yeah, a couple of scratches
stains.
here. There, the tracks get a bit scratched. They're worn.
That's it. Yeah.
Bit of dirt flying up around the mud guards stuff.
The problem is there's so much stuff out here to do all that, and I'm still learning to use it all.
Oh, okay. The weathering
I've got
side, yeah.
I've got jars up there that have got specific types of dust and dirt as to what part of Europe it's in, and you've actually got you've got mud, and it's a wet substance, and you can stipple it onto the model and just wait for it to dry. And that never used to exist when I was a kid. Yeah, stuff like that.
No, they were
hadn't
just
been
put together basically, weren't they, when we did them back
Yeah,
then?
and if you wanted to weather it, you had to get creative and invent ways of doing it. Well, it's all there now. I've now got oil brushes, and they are there to replicate specific types and colours of stains and things. And I haven't learned how to use them yet. I think I've got to buy some cheap old kits, cobble them together, spray them up, and then just practice on them. It's time and it's motivation at the moment.
Yeah.
I ain't had the motivation.
Well, that'll help a little bit if you could glue a piece together once every now and again. I don't know how you're going to do it live though. That'd be the tricky bit.
I think I can probably do it here. I'll just have to angle the old webcam down so you can see what I'm doing.
Well, it's a shame you didn't have a little table with little 4 legs on it that you could sit over your keyboard area, so it lifts it up a bit higher and your camera could see it.
I'll have to have a play.
Yeah.
I'll have to experiment and see what I can come up with.
Because there's certain components on tanks that are, to me, are interesting, like how they function. But I don't know how well the model details a lot of that stuff.
That's something else we've now got. All the little fiddly pieces. Whereas before it'd just be moulded in plastic, and to scale it'd be quite thick and chunky. It's all now done in etched brass.
Okay. Have you seen those big tanks? The radio control style ones?
Yes, they're very big, very expensive, and
very heavy too. I watched the bloke drive one up the back of ramp into the back of his car. Like you could see the car and the ramps go down as it went up.
Yeah, because ones that size, they are made of metal. They tend to be aluminium. But yeah, everything's metal, because if it was plastic, it wouldn't last 5 minutes, would it?
No. You could nearly have a tank war with them, really, with live ammo.
I once saw a large scale one at a model show years ago, and it actually had a functioning main gun. It was a 410 shotgun, and he had a license to go with the model so that he could shoot this shotgun. But he'd modified it so it looked like it looked like the real thing. It looked like an 88mm cannon or whatever, but it actually fired shotgun shells.
Yeah, but tanks projectiles are not shotgun shells. They're just ape.
No, but yeah, but he could sit there and trundle this thing along and turn the turret around and press a button and it would go bang and hit a target.
Yeah, just bear with me for another minute.
You're doing a brew, aren't you?
Whatever give you that idea?
Because you're in the kitchen. Enough. Bugger, my thermos is empty. Damn it.
This is ASMR making coffee with Terry.
Yeah. Hello and welcome to Making Coffee with Terry.
You've seen how many different ones they do now of them? Everything from cutting wood to, I don't know, all sorts of weird things.
Yeah, well, I suppose people, think, oh, this is a good idea. Let's see if this works. And if they get viewers, yeah, go for it. But
Or you could watch a 24-hour stream or 12-hour stream of rain or something to help you sleep.
Yeah, vodka, that does it.
I could do a Riley in the kitchen too.
Really? What, pee in the sink?
No, just pour water into a container.
Hello and welcome to another Riley moment.
I say, oh boy.
Yes, David, that is how they used to do it, crushing up pastels and things. But now, I tell you, you can get all sorts of various oils and acrylics and enamels, mud, dust, dirt, oil stains. I've got so much stuff over there, but I've got to learn how to use it.
That's one thing you haven't done yet, is grabbed something from the kitchen that's an oval shape and it's a light colour and brought it up in front of the camera and gone. Quote, and do that quote.
I can't do that at the moment because I haven't got any.
Oh, okay. I'd do it, but I'd have to turn the light on and to see.
Look, when I go shopping during the week, I'll get some so we can have that moment next time.
Yeah, it freezes when I share the screen to the Zoom call, and then it freezes from them out there. But anyway, we've got 3 videos. We've got Simon, Phil number 4.
4.
Yep, and Blue Marbles, Oakley and QE's curved adjacent nonsense.
And it is nonsense.
There we go. And we'll play them in that order.
Coolio.
Cue the audio. Yep, audio ready. Next.
Where's Blue with his sign? Oh, he's missed. Never mind. Press play, please.
We're just waiting for the P word. That's all we're waiting for.
Progress.
Let's play.
Through endless flat earth videos to try and find the absolute best failures for you. Yes, it's flat earth fail compilation time yet again. Hello all, welcome along to another episode of Flat Earth Friday with me, Simon and Dan. Thank you very much for joining me. Before we begin today, a thank you to the sponsors of today's video, Noom. Now, Noom is a consumer-led digital health platform which uses coaches, psychology and science to help people give them a push to look after their health boys. Click the link in the description to take your free Noom evaluation. It's quick, easy, and will help you create a custom plan. Right, back to today's video, which, as I mentioned at the start, is a Flat Earth fail compilation one. Episode 32, no less, and we start with our old friend, Mr. C.C. Chris from New York, Westchester County.
Good morning, good evening, good afternoon, wherever you may be.
What is in the kitchen?
C.C. here, Chris from New York, Westchester County. It's 1:17:22.
His wife mustn't be home.
We've been fed this lie of a globe all of our lives.
You know, I actually think CC does believe it's flat.
Throughout middle school, nursery school, the minute you walk through that classroom, you see a globe. Why?
For the same reason that you see A, B and C, to learn.
Why is it in every classroom? Why is it in every single classroom where you see a globe? It's there.
He really hates it, doesn't he?
It's there to lie to you. To reiterate this lie. Bullshit. You don't live on that globe you're looking at in school.
No, we absolutely don't live on the globe in the classroom. We live on the big one under our feet. Little joke there.
You live on a flat, stationary Earth. It's not a flying disc in space, because there is no space. You're covered with a dome. Stationary. Standing still. And you're not moving. And if we were moving, explain to me how the weatherman could actually predict the weather from 3,000 miles away to where you are 3 days prior.
Because the
What? Predict the weather from 3,000 miles away. Ah, okay.
weatherman has trained and learned for most of his adult life about meteorology. They understand how weather works and the patterns ingrained in it. They study the weather in their region and how different aspects of it can affect that weather. Then they use computer programs which has been fed the history of all the things that weather has ever done, plus the conditions at the time to predict what's going to happen.
Well, even today, standards with weather predicting has gotten a lot better over time, with all the different modellings and data that comes in, which is more useful for us, I suppose, for now.
it's really not that hard to see how they can do that.
How is that? How is that possible? Unless if he's a mathematician, and he's taking into account that the Earth is revolving at 1,000 miles per hour, and the clouds are moving in at 40 miles per hour. It doesn't make any sense.
Well, apart from the fact that the Earth's rotation does have an effect on Earth's weather systems, when you predict the weather in a local region, the Earth's rotation itself is pretty much ignored.
Does it? Think about it. Think.
Maybe you should take your own advice, CC.
You probably weren't even taught that the Earth was revolving at 1,000 miles per hour. I wasn't.
No.
Well, actually, I was.
I don't think anyone would have been taught that. They would have been told how it rotates, 15 degrees per hour. Thanks, Bob.
But I learnt about angular velocity as well. You know, the old 15 degree...
A 15 degree per hour drift.
Ah, sorry, Bob. Almost stole your thunder there. Little weather joke.
So did I.
Thanks, Bob.
Nobody in no science teacher ever even told me about that. Ever. These are things that they don't teach you about in school, at least here in America. So ignore these trolls below me. Because they're children. That's all they are. Children. Or they're paid. Either way you look at it, I have no idea.
Paid? Of course you would think that, CC.
But just ignore them. Because I went after the source. The biggest troll of the entire internet.
Wow, the biggest troll of the entire internet? They must be massive.
When it comes out of flat Earth, and that's Cy Dan Man.
He keeps doing this. It's Cy Man Dan, CC, not Cy Dan Man. Come on, matey.
Yeah, I asked him to do a live debate with me. A live debate. Uncut. Live.
Did he do it?
Once again, I have heard nothing. This is my third attempt.
Well, I did ask you to email me, CC, but my comment disappeared. So how about this? As you know, I don't debate the shape of the Earth. It's just not up for debate. But I would like to have a chat with you. So please email me, simondan@gmail.com. Moving on, we're looking at the channel Sun, Moon and Zodiac Clock app. Something David Weiss has done, I think. And here Mr. DITRH himself is discussing how he got into Flat Earth.
So how'd you get into the Flat Earth, though? Like, specifically Flat Earth? Well, so people started sending me Flat Earth stuff, and I literally ignored it. I said, this is dumb. I'm not looking into this. You're an idiot. And I blocked people from my social media for even suggesting that I look into it. So dumb. But then finally I got tired of it, and a researcher that I trust very much, she said to me, I think the Earth might be flat one day. And I said, oh, come on, not you too. And she goes, watch this video. And she sent me a couple of videos. And I was like, that's interesting, but the Earth is definitely not flat. And I started researching more. This was back in 2015, 2016. And that was back when you search Flat Earth. Google, YouTube would serve you the current real stuff that people were looking up. And I spent 2 weeks, day and night, trying to come up with one proof of the globe. You know, Sticks and Shadows by Aristophanes, Boats Over the Curve, Day and Night, Seasons. None of it holds up when you actually look at it.
Well, it does. But what's interesting is that you Flat Earthers have been asked time and time again for a Flat Earth model that simultaneously takes all of the things you've just mentioned there into account. Yet you have failed at every opportunity. The globe model predicts all of those things at the same time.
You guys believe that the Earth is a ball, but you have no idea why. Like, I could ask you, how fast is the Earth spinning? You don't know. How fast is it orbiting the sun? You don't know. How far is the sun? You don't know. Right?
Well, we have Google for that, though.
Well, I know, but Google...
The sun is 7 million miles away, I think, isn't it?
98 million miles away.
93. All of you are wrong, and those answers are even wrong. But how did they figure out the distance to the sun? It's nonsense once you look at it. You were told you believe. Belief is the enemy of knowing. When belief is easy. You guys believe I live on the East Coast because I told you. You never verified it, so you believe it. But if you took maybe an hour or two, you could verify. You can find my high school yearbook, maybe find me on Facebook. You're like, yeah, this guy definitely is on the East Coast. Then you'll know. But until then, you believe. Belief is easy. Belief takes no effort.
So, just saying he lives where he lives without doing any research to verify what you believe.
Isn't David Weiss religious? Just saying.
Knowing takes time and critical thought. And once you know that you are at the center of creation, that you are way more powerful than they led you to believe, then things change.
Yes, you become someone who believes YouTube videos over actual scientists. Dear oh dear. Next up, we have a channel called Delete My Channel Again FluTube. Bit weird. Who apparently has proof of a flat earth. Here we go.
Alright guys, I got a standard map of the world here. And what I'm going to do right now is look up flights from New Zealand to Argentina. And should be a pretty straightforward flight as we can see from the map here. But let's see what Google Flights has to say. So I've got Auckland, New Zealand to Buenos Aires.
We predict what he's going to do here.
I'm going to hit search.
It's not going to show it on Google Earth, is it?
On the flight here. 2 stops, LAX,
It's not going
JFK.
to show that flight on a sphere.
Okay. Auckland to Los Angeles to JFK, JFK to Buenos Aires, Argentina. Huh, interesting.
Not really. There's a reason that flights make stops, and that's usually because the airline you're flying in stops in the country that it's based in. It makes more financial sense to do it that way if you've got a lot of people who are coming from New Zealand who want to go to Argentina. But I did find a one-stop service that actually stops in Chile. And where is this airline from? Bingo. Chile.
Let's look at the map again. So they want you to fly from here all the way up there, and all the way across the United States, and then come back down to Argentina. Why do you think that is?
I've just explained, and additionally, that deviation looks a lot worse on that map projection you're using.
Does that make any logical sense at all? Now what I have here is the standard flat Earth model.
Oh, here we go.
Of the world, Gleason's map. And here, this is New Zealand.
It's lost a hand.
According to that flight, we'd be going New Zealand to LAX, there, and then down. It's pretty much a straight line.
It makes more sense on a flat Earth.
That's it. That's all you're going to say. Pretty much a straight line. Well, that's it, everyone. He's cracked it. Utterly ridiculous, especially after I've shown that that's not the only route. Okay, our final video today comes from Jake the Arsehole, who has apparently debunked the Chinese space station.
What's up, guys? Jake here. Last week I posted a video called Chinese Space Station Exposed. In that video, I showed you guys that China now has a fake space station, and they are producing some terrible, low-quality, fake space videos.
They actually look really cool. Need to check those out, actually.
Now, it didn't take long for the comments section to fill up with a bunch of people pointing out the exact same anomaly over and over again. And when I went back and looked at it, it's a perfect example of space fakery. Now, I want us to all take a close look at this scene. Here we see a Chinese astronaut strapped to the wall, pretending to be floating around in outer space in zero gravity.
Well, I don't think he's doing that. He's cycling. A clear example of trying to stop the muscle and bone degradation that happens if you spend too long in space.
Now, what everyone seemed to notice, and I missed the first time I watched this video, was these bags off to the right. You see these bags over here, these objects? Why aren't they floating? Are they glued down? Are they tied down? Seems to me that these objects over here, whatever they are, should be floating around.
Most likely Velcroed. But quite amazingly, Jake has an issue with these bags, but makes no attempt to explain the man just floating on his side for ages on the clip earlier.
Right? Now, the strangest thing I found, and I had to look real close, is at the end of that white rope tie, or whatever it is, on that blue bag, you can see a CGI glitch that happens. Some sort of weird CGI glitch anomaly happens at the end of that white rope tie, and I can't make any other sense of it other than it being some sort of editing mistake.
Out of
because you're
all the
letting your
footage,
bias get in the
you're
way.
looking at this and claiming this is the reason it's fake. Talk about desperation, Jakey boy.
Some sort of CGI glitch editing mistake that they were just too lazy to go back and fix. It seems they don't care if their stuff looks low quality. They don't care if their stuff looks fake as funk.
No, they don't care about the flat earthers who are watching that call out literally nothing.
That's because people are so damn indoctrinated and brainwashed, they will believe anything. But for those of us still paying attention, CGI glitch and the logical matter of the fact that these bags aren't floating away is 100% a perfect debunk. This has been just another opinion from Jake the Asshole. Please like, share, and subscribe, and I will see all you lovely assholes next time. Peace.
I love it. This is absolutely fake, but it's just my opinion. Well, there we go. Another Flat Earth Fail compilation, all done and dusted. Thank you so much for watching today. It really is appreciated. If you enjoyed it, please do subscribe to the channel. There's a playlist of all the 31 compilations, Flat Earth Fail compilations that have come before this one. Go and check them out. Episode 1 is still my favourite. And if you really enjoyed it today, hit the like button. Just enough time to once again thank Noom for sponsoring today. Remember, click the link in the description and you can take a free evaluation right now. I've been Simon Dan. Have a great weekend and I'll see you on Tuesday where Jason Maggard returns. Oh, it's great to be back. See you then.
That says it all, really, doesn't it? There's a Takenaut, I believe they call them, floating sideways in the space station, stuffing his face. But no, let's concentrate on a low-res image of a drawstring of a bag.
Yeah.
I had to really look hard for this. What, you had to push matey boy out. Excuse me, can you float over there? Right, what's going on over here? You know. So that space station's fake. What about the one that was up before it? Because that isn't the first Chinese space station.
I like the answer somebody gave. Yeah, the bags are obeying somebody's first law of motion. Object that stays in motion, unless acted upon something.
Correct. An object will they're just sitting there. Nobody's doing anything with them. That and the fact that they might well. Certainly, if you watch any footage from the ISS, everything's got Velcro on it. Everything. So they can put something down and it bloody well stays there because there's Velcro everywhere and everything they hold, their clothing's got Velcro all over it, their iPads have got Velcro, everything's got bloody Velcro on it, so they can put it down and it stays there. You know. But no, the end of a drawstring on that's it. Not exactly filmed at 1080p, you know.
Yeah. Well, you see a lot of those little glitches with the low resolution camera.
Yeah. You mean the end of that drawstring that was just floating up in the air for no damn good reason?
That's it.
That one? Yeah.
Yep.
Okay.
Yeah, it wasn't hanging down. It was just in one spot.
Oh, the other one was sticking straight up. That's either a really stiff drawstring or something funny's going on.
Yeah. Oh look, they're all on wires and cables and harnesses. Yeah. So how come their watch is floating around their wrist and some of them got chains on and they're floating up and their clothing's floating up and everything's floating up, but no, they're on harnesses. Yeah, sure.
And the clothes always look baggy because there's no.
Correct, because it's not sitting on you as it would here. They do tend to float.
They're floating around with you.
And you can see they're always trying to figure out what to do with their hands. Because if you don't do anything with your hands,
where do you
your
put
arms
your
just
hands?
tend to float. Yeah. That's why they tend to sort of clasp one hand in front of the other in front of them, because it's like if I don't do anything with my hands, my arms just float about.
Float around,
yeah. No, it's all fine.
Yeah, gravity.
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 I don't think they understand the gravity of the situation.
No,
I don't think so.
I'm down with gravity.
Oh.
It'll never end. You'll get your psychos every day.
Yeah.
One will come along, get one down. She'll be right.
Here's a P word.
Yep.
Press play.
No, Phil.
No. Professor
Oh,
Phil.
Phil.
2 P's.
Sorry, missed my cue. Okay, take 2.
Okay. And you saying I won't get copyrighted this music?
I don't think so.
I know that bloke.
Hello folks,
And the
welcome back to my channel. My name is Professor Phil, and
Oh,
this
hi,
video
Phil.
will look at the issue of things going over the horizon, which manifests as disappearing bottom first or arriving top first. Now those of you who have watched the first 3 Flat Earth vlogging videos will be aware of Mrs. B. You also know that Mrs. B doesn't believe flat earthers are as dumb as bags of rocks. Her initial view was that the flat earthers are big time trolls. Well, after looking at the evidence, I think we can compromise. The fact is, some flat earthers actually run businesses and hold down jobs, so they can't be as dumb as a flat earther needs to be to think Earth is flat. The alternative, other than troll, is that they have other motives that fulfill some psychological or social need. Let's consider this example. Surely nobody actually believes that a snake talked, or that 2 kangaroos and their wombat mates, plus a couple of echidnas and koalas, hopped and ran all the way to a boat in the Middle East and then back again. I wonder which state they settled on initially, and how in just 6,000 years got to populate the entire Aussie continent, as well as develop different species of macropodidae, such as our boxing kangaroo, Macropus rufus, and who knows how native Australians got here. My point is that people act as if they do believe it for reasons that have nothing to do with the facts. But that's okay. They can rationalize it by declaring anything is possible if God wills it to be. I understand that. Or you can be like most Christians and Jews and accept that the Bible contains allegorical stories. I get that too. But they are not passing off these allegorical stories as science. That's the difference. So Gary Wabenga, you're off the hook on being labelled a bag of rocks level dumb. 10th Man, Quantum Eraser and Flatzoid? Not so much. Maybe your flat earth teacher Mitchell should have a quiet word with you. Now let's pick on Gary to help us tackle the subject of this video. So the problem comes back to objects being obscured by horizon. I'm deliberately not addressing the black swan photo in detail in this video. I will take on that nonsense and the charlatans and liars promoting it in another video. So let's first look at some examples of objects beyond the horizon and then discuss what Gary Wabenga and others pretending to be bag of rock level dumb say about it. Here is a static example of objects observed to be over the horizon. Notice that the further back they are, the less of the bottom we can see. Now the charlatans will immediately refer to geometric horizon versus apparent horizon, as if they magically cancel each other out, rendering the earth as flat. Well, get this through your thick heads once and for all. Boats are obscured by actual water at the horizon. The location where you observe this horizon and how much or how little it does obscure depends on the atmospheric conditions near the surface of the water body. Exactly like if you climbed a hill, you get to see more of the objects and the horizon is further away. I know many struggle with this. That is how the charlatans get away with the scam. They rely on creating confusion among bag of rocks level dumb people so that they can fleece them. Neither the charlatans or their victims have any discernible self-respect. However, if we examine the tops of the turbines, no matter how far they are, no part of the blades have reached the diffraction limit where we can no longer resolve the detail. Neither are the turbines far enough in the distance such that perspective makes them too small to resolve. In fact, we can see the blades perfectly. We can see the detail, and we can see the change in angular size is not representative of objects very far away. Clearly, we can't see the bottom because the water at the horizon is blocking it. Can we use this observation to determine if Earth is a globe or flat? Let's work on that. What would we predict if Earth is flat? Well, firstly, without doubt, the turbines would get smaller and smaller in all directions until we could no longer resolve individual blades. But we would still be able to see the whole lot to the water. To get to resolve the blades again, we only need a bigger telescope with a wider aperture. We could therefore always see the turbines as long as the atmosphere allowed us to. There is no mechanism on a flat Earth to explain the actual observation. No diffraction limit, no significant change in angular size because of the perspective, just progressively more of the bottom obscured with distance by the horizon, and no hope of using a larger telescope to view more of the bottom. If you're not convinced already, then have a look at this row of fishing net poles. Notice how they get smaller the further away they are. Look at these electric poles across the water. Notice that they get smaller. Look at the light pole illustration and the light spot underneath each pole. Look at the trees. A good telescope would allow you to see all of the trees in the distance. This is perspective, Gary. No elastic band parlor trick, replete with made-up physics and word salad, is needed. Stop bullshitting to yourself, Gary. So what if the surface is curved? Then, as objects move further away, the globe model predicts that we will see progressively less and less of it from the bottom. This is precisely what we observe. In fact, if we now examine both flat and spherical, it becomes abundantly clear that even if we accept that the wind turbines closest to the observer have their bottoms obscured because of foreshortening or smooshing or other made-up reasons, it does not explain why the turbines further away have even more of their bottom smooshed. What about the turbines that are directly in front of the others further back? There is no smooshing involved, so why can we only see very little, just like the blades? I heard Gary on various channels squirm out of this type of questions by making up his own laws of perspective and physics, but never any coherent explanation for what we see with the turbine farm. My challenge to Gary or anyone else is to explain the observation based on a flat surface. Number one, why do the bottoms of turbines disappear long before any diffraction limit is reached? Number two, why will a telescope not make it possible to see more of the turbines, much less the bottoms? Number three, why are the turbines being blocked from view long before they get too small to see? Number four, explain the observations we get as a result of this ship moving away. Number five, why can't we use a telescope to see more of the ship? Yet we could see the whole ship if we increased our elevation. Now, consider the black swan photo and another photo by the same camera from the same elevation at a different time. Why are these photos different? If foreshortening, smooshing, or other reasons explain half the rigs missing, why are these reasons not the case in the black swan photo? To anyone who does not have a cult-like reason to convince themselves that they should hide from reality, it's clear that only a globe model explains the observations I have demonstrated. The fact is, you cannot unsee what I showed you, Gary. You can squirm around desperately trying to make your own physics, but you know it's bullshit. You can even try the Oakley trick by introducing semantics to hide behind. Of course, Oakley has an excuse. He needs the bullshit to make a living by fleecing genuinely mentally challenged people. But what's your excuse? A desperate need to feel special? You know that you must lie to yourself in order for you to continue acting like you actually believe Earth is flat. The alternative is that you are genuinely mentally challenged. Short of an assessment, let's say, how about you choose which one suits you? Well, folks, I know that to people with normal intellect and no ulterior reason to bullshit to themselves, this Flat Earth flogging video has flogged Flat Earth to death 6 ways from Sunday. And the next flogging of this now well and truly dead horse will be even more devastating for Flat Earth. Please watch out for yet another Flat Earth flogging video that I will release very shortly. Please like and subscribe, and please write a comment. Flat Earthers are welcome as well. Just be reasonable. Cheers.
There you go.
What's happened here? I've lost the bottom of
Lost your bottom?
it. Yeah, I've lost the...
Bottom.
What's going on here? Something's not right.
The bottom's fallen out of his world.
Bottom. Yeah, there's
I'll
a
go back
series
to
I
there.
wouldn't mind watching again.
Yeah.
ABC's series, Bottoms.
Yeah, I don't know what's going on. I must have... Trying to work out what's going on. I can't get to the bottom of the bit to press play.
Bottom of the bottom.
How have you managed that?
I don't know. It's all gone weird.
It's all gone Pete Tong.
Okay. Oh, I see what it is. I think. I bumped the default view.
Ah.
Now all of them are default. Now all of them went to the theatre mode. Just check to make sure that one's working. Yeah. That's right. Don't know what happened there. Must have been a shortcut key or something. Let's fill out of the way. Yeah, I always post up those ones with the wind generator turbines.
Oh yeah.
I like those ones. Oh, I heard that. I heard a cork.
I'll have half.
I had a naked person out there before. Who was that? Mallory's Asylum. I asked him a question and I didn't get an answer. I don't know if they've lost their spanner or they're a newbie.
I don't think we've seen her here before. Not sure.
Yeah, I asked if you were already subbed or lost your spanner or are you new? I have to wait till an answer now. I'm not going to retype that out again. Oh, how long have we been going for, Paul? Is it past our bedtime yet?
Yeah, it's nearly 2 o'clock.
Yeah, it is.
In the morning.
Yeah, it is too. Nearly 3 o'clock in the afternoon for Farmer and nearly 10 o'clock for Blue.
Yeah, 1 o'clock here.
Yeah, you don't believe in time up there.
Time is an illusion. Yeah, we go 4 hours.
Yeah.
Oh, we only got Blues to go and then we're done.
Righto.
Press play.
Oh, wait a minute, I haven't shared it with
He
you
hasn't pulled
yet.
it up yet.
There we go. Already at my end.
Press play, please, Terry.
Okay. Oh, we've got a referral from Jedler. Okay.
Well, hello everybody. Welcome to Blue Marble Science. Nathan Oakley and quantum erasers curved adjacent nonsense. Of course, they're wrong as usual. Warning. Severe facial and monitor damage alert is in effect. Get out those oven mitts. Push the monitors back out of punching range. And let's light this dumpster fire and have some fun. Here's Nathan Oakley and quantum eraser berating a guy named Highlander over the method Alberini used to estimate the radius of the Earth. Let's give a listen.
Not just welcome to Flat Earth, welcome to geometry.
Yep, they have no clue. Highlander, do you understand what he's asking you for the past, 40 minutes? Let me break it down for you. He's asking, why did Alberini use planar trigonometry to conclude a spherical radius? That's the question.
Huh?
Okay, let me try it again.
So you understand now Alberini's got to have a flat earth underneath this mountain to get this triangle. He couldn't do it if it was curved, because he wouldn't have a flat baseline. Maybe interrupt the devastating fact that he couldn't do the measurement if it was curved. Or maybe laugh in the face of the fact he can't do this unless it's flat. It's got to be he can't make a triangle unless it's flat. Do you understand that part? Geometrically illiterate globe believer. Yeah, I know. You don't like being told that there are no flat surfaces on a sphere, or that Alberini's absolutely measuring a flat plane to get his height of the mountain. You don't like these things, sphere believer. You can't tolerate them. You give me your high-pitched squealing giggle when you hear them, don't you?
So funny, Nathan.
So what's the argument? Well, according to Nathan and QE, you can't have an angle between two curved lines, or a curved line and a straight line. And that's just pure nonsense. This is taken straight out of Wikipedia. The angle between the two curves at P is defined as the angle between the tangents A and B at P. This is not a new concept. This has been around since the time of Euclid. But it doesn't have to be necessarily two curves. It can be a straight line and a curve. There's a straight line, there's a curved line. The angle between the straight line and the curved line is the angle between that line and the tangent to the curve at the point the line intersects the curve. By definition, that's the angle.
That was nice, that, wasn't it?
Oh, thanks, Biff.
Level is horizontal.
No,
I still reckon you say it better, Farmer.
And I'm going to do a special video for you on that. But hang around, you still might learn something anyway. Alberini was an 11th century
copy your
mathematician,
version
among
of
other
it.
things, also known as the father of modern-day geodesy. You do realize that requires a geoid. Anyway, Alberini developed a method to estimate the radius of the Earth by measuring angular drop to the horizon from a known elevation. Notice I said estimate, not exactimate. This is an approximate method, and atmospheric refraction will affect the results. But it'll give you a reasonable answer under most conditions. It works like this. You find a nice mountain someplace, and you measure the height of the mountain. Then you take an astrolabe to the top of the mountain, and you sight the horizon at some point, like C on that diagram. That gives you angle alpha. You now know the height of the mountain, and you know alpha, which is the dip to the horizon, and you simply plug it into Alberini's simple equation shown there on the bottom left, and you get an approximate radius of the Earth. Now here's the problem. Flat earthers are absolutely terrible at looking at a cartoon like this and trying to relate it to reality. It's only drawn this way for clarity, but what they see in their minds is a triangle that looks like that.
Exactly.
With nothing approaching a right angle and a great big whopping curve in the bottom of it. What they fail to realize is if that were the Earth, you're looking at a distance across the surface of maybe 2,000 miles. That's absolutely ridiculous. You have a hard enough time seeing the horizon 50 miles away, much less 2,000 miles, and most of the time it's more like a couple of miles. But there's another point to be made here. Al-Biruni used a device called an astrolabe, and an astrolabe is a gravity device. It hangs like a plumb bob, and the measurement is actually made to a perpendicular to that plumb line. That line is this line. The surface of the Earth is not being used to make this measurement. Only a visible point on the horizon. That's it. The measurement is being made from a level line at the point of observation. That's what angle alpha is measured from. So Nathan's assertion that we're using a curved adjacent is just flat nonsense. Now, Nathan and QE see a diagram like we have on the right, and they instantly insist that the Earth has got to be flat to make the measurements. Frankly, those two are too geometrically challenged to figure this out. So let's see if we can help them. Have a look at the diagram. First, we need to find ourselves a nice mountain, like that one. Then we need to find a nice beach next to the mountain, and a point on that beach where we can make an angular measurement to the top of the mountain. Then we need to move a known distance from that point and make a second angular measurement. So now we know the two angles and we know the distance between the measurements. All we've got to do is plug those numbers into that formula and we arrive at the height of the mountain. It's that simple. Now again, we're That's using basically the just the law astrolabe of to make science. these measurements.
Yeah.
So at no point does the shape
I didn't realise you
of
could
the
do that.
surface we're standing on make any difference. Those angular measurements are made with respect to a line that is perpendicular to the plumb line at the point of the measurement. They have nothing to do with the shape of the surface, flat, curved, or otherwise. This is exactly the mistake flat earthers make when they try to understand sextants and how they operate. Now let's have a look at a drawing that's made to scale. There's the little diagram we saw. So we start by picking a point on the top of the mountain. Next, we pick the first point that we want to make a measurement from, and from that we measure the angle to that point on the mountain. That's angle alpha. Next we pick a second point, a known distance away, and measure that angle. We call that one beta. Now, if we plug in the known distance between those 2 points, in this case 5,280 feet, and those 2 angles into that formula, we get a mountain height of 1,999.98 feet. That compares very favorably with my scale drawing, which was 2,000 feet. Again, keep in mind that that measurement is being made with an astrolabe. It only knows the direction of gravity, and the angular scale is relative to a perpendicular to the direction of gravity. So the shape of the so-called baseline never comes into play. Only that line perpendicular to the direction of gravity. No baseline is involved. Here's the globe model. Now, if you're looking at this thinking that that baseline is straight, it isn't. That is a curved baseline. I'm going to show that to you in a minute. Notice that before we had a predicted height of the mountain of 1,999.98 feet. Now we've got slightly different angles for alpha. Beta remained constant. Alpha didn't. Angle alpha increased slightly, and that results in a predicted height of 1,997.792 feet, off by 2.2 feet roughly. There's a reason for that. If the gravity vector is that direction when we're measuring angle beta, the gravity vectors are not parallel. When we measure angle alpha, the gravity vector, this is exaggerated, is tilted like that. So you get a slightly larger angle. And that's what results in that error. Now let's have a close-up look down on that end. Remember, I told you that that is not a straight line. That is actually an arc. And it results in a displacement, a drop, if you will, of 32 inches from the point where we measured angle beta. There's the curved line representing the ellipsoid. There's the radius of 20,900,000 feet. The total error is about 4.86 feet, less than 5 feet difference. Will that matter? I don't know. Let's find out. Here are the two scenarios in Walter Bisland's Earth Curve Calculator. If we start with what Alberini would have measured, and if we plug that mountain height and that dip angle into the equation Alberini developed, we end up with a radius of 3949.112 miles. Now let's go to the globe model and use the 2003 foot elevation. I'm going to keep that dip angle the same. And when we do that, we end up with a radius of 3958.759 miles. Only about a 10-mile difference in radius, that's all. Now these numbers are unrefracted, and this is where the error in the Alberini method comes into play. If we include refraction, we get a measurement that's going to be about 175 miles greater. That's using a mild refraction factor of about 0.04. Standard refraction is around 0.16. So this is the reason that the Alberini method is a bit unreliable in terms of precision, but perfectly demonstrates the curvature of the Earth. Now there's one more thing I want to point out. There's the flat plane model on the left and the globe model on the right. What's the length of that line that the flat earthers like to call the baseline? Well, we can measure that. AutoCAD tells us that the length of that line is 10,560 feet, exactly 2 miles. What happens when we do the same thing with that curved line on the globe model? The length is still 10,560.0004 feet. This is why, if we want to, we can treat that so-called baseline as if it is a straight line. Even though it's got a slight curvature, it really makes no difference. You know, 2 miles is less than 0.03 degrees of the surface of the Earth. If we carry that out to a full degree, that's 69 statute miles. The difference in the chord length and the arc length is less than 5 feet. Nathan, your curved adjacent argument is simply a red herring. You guys are going to need to do better than that. I got an idea. Why don't you do this? Why don't you show us how you can take a sextant and find your position on the flat Earth? That would be really interesting. Hey, thanks for watching. Hope you guys enjoyed it. Don't forget those little buttons down there. Shout out to the members, the patrons, PayPals. I appreciate everything you guys do. And I'll see you on the next one.
Yeah, nice little demo, that.
Yeah, I get tired of listening to those guys whinge about curved baselines.
Yeah, it's nonsense, isn't it?
Gets old, isn't it,
It's,
Mike?
it's a damn tempest in a teapot.
Yeah.
Can I pick out your spelling mistake, please?
Huh?
Can I pick out a spelling mistake?
Probably.
Okay.
What does I spell wrong?
I've got to find it now.
I make them all the time.
I know, it's like a Where's Wally sort of thing sometimes. Oh, there it is. I found it. The peanuts won't be able to see. That way they won't know. They can find it themselves. It's in that.
Oh, yeah.
Why isn't my Star Trails working for some reason? Did you find it?
What did I do?
A spelling mistake. I'm sharing it. Peanuts can't
Oh,
see it.
live. Live. That's not a spelling mistake. Live's a word.
Oh, okay.
I spelled it perfectly.
Okay,
Yep, he spelt that word perfectly. Yeah.
Bugger,
Yeah.
That's the problem with depending on spell check.
Yeah.
It knows how to spell the wrong word perfectly.
Yes.
Oh, there we go. Now I figured out what happened. I didn't tick this thing for the video. Alright. Yeah, I think that'll do us, Paul. I think it's getting really late for us over here.
Yeah,
I've got to get up at 6:30 too.
Oh. You've got to be up before your students. Oh, you were getting you were cleaning out, weren't you, this week or something?
Yeah, I've only got 4 sheds now, so it's a little bit easier.
Oh, well, I'll type me goodbyes out there. Your answer to your question for the scientist?
Clyde Tombaugh.
And what does he do when he's home?
Well, he was the one that discovered Pluto, but he also discovered a lot of asteroids and a lot of minor planets in the Oort cloud and Kuiper belt and stuff like that as well. So, yeah. And he was an advocate of doing further research to understand the phenomenon of UFOs.
Oh, okay. That's a different field altogether compared to planets and asteroids.
Yeah. In other words, he said, let's not just call them UFOs, let's just find out exactly what we're seeing.
Yeah.
Yeah.
Oh, we haven't got Alan here to tell us of his exploits not lately, so we missed out on that one.
Now here's a good bumper sticker. It says, sometimes when I close my eyes, I can't see.
I find every time I close my eyes, I can't see.
Yeah.
Very profound.
Yeah. It's very deep, yeah.
That's like the old one I learnt when I was younger. Confucius say men stand on side of hills. Confucius say men who stand on hillside, not on level.
Oh, Confucius say women who fly upside down have crap up. You know, you go that way if you want.
I always find at the end of the day, it gets dark.
Yeah.
That's deep.
Confucius say, tight pants like small hotel, no ballroom.
Yeah, my ballroom. Yeah, very true.
What else have we got here? That and one more.
It used to be a dance room up here in Brisbane. They call it Cloudland, but it was all ballroom.
Did you get that, anyone?
No.
Are you in the same room as your microphone, John?
No, I don't think so. It was Cloudland, you know, plenty of ballroom. Okay.
Okay. What are you going on about, Jose? 3 more hours? Yeah, you stream too bloody late. Like, what time of the day is it over there now? 10 o'clock in the... Well, I don't know if he's East Coast or West Coast.
He's East Coast. He's 5 hours behind us, so he will
East
have.
Coast is nearly 10:30 in the morning.
It's sort of 10:15 in the morning.
Yeah, 10:17 because the same minutes as you and me.
That's it.
East
Yeah,
Coast.
it'll be 10:17.
Yeah. Oh. Like I used to catch him in the middle of my afternoon, so that would have been late at night then for Jose. At one time.
Yeah.
Men who fart in church sit in own pew. Yes, Little Wolf?
Yeah, that's very sage. Yeah.
I think we only got one peanut that come up with something.
Here's another good one. You can't scare me. I was taught by nuns.
Yes, I've heard that about them. Yeah.
True.
Baseball wrong. Man with 4 balls cannot walk.
Dyslexics are teeple poo.
Well, I've done my bit.
Have you done your bit?
I've done my bit. My eyes are funny. Everything's blurry on Blue's background.
No, your eyes are fine.
Oh, are they? You sure?
His background is blurry. Yeah.
Oh, okay. How come Blue's not? They CGI and the background's real.
Yeah,
That's
it.
right.
Yeah, blue CGI. You silly ass.
Okay, Clyde, Tom Barr. Thanks,
Yeah.
John. Thanks, Farmer's little boy. Thanks, Big Blue. I'm not going to say the rest of that one. I was thinking. Peanuts, Delirium, John, Little Wolf, David Oliver. Oh, that bloody scroll function.
Oh no, it's annoying, isn't it?
Delirium, David Oliver, Little Wolf, Judy, Jose. Gotta scroll up. Jezza. Had a couple of new people join up without a spanner too, although Dora was off to do some shopping. Okay, missed out on saying goodbye, Dora, sorry. My mum bakes cakes. I haven't heard from them for a while. RT96. I know Clive was there. There's Facty. Yeah, Mallory's Asylum. That was one. There was another one too before that. Elmix. Did I say Jezza? Fred Bailey.
Once upon a time, a guy asked a girl to marry him. She said no. So the guy lived happily ever after.
Carl. Well, that's your homework then, Paul. Another one, a bunch of them then.
Yeah.
You've seen that you already found some. We got some bots that came through earlier too. I noticed that people timed them out. Thanks for that.
Oh yeah, there
Peanut.
was.
Yeah, thank you.
Yeah, I
Peanut.
think there
They're on the
was at
ball.
least one.
Delirium Celestia. Yeah, that's it. I think. Did I say David Oliver before? Anyone I miss out on, you better wave goodbye now. Otherwise, you won't get a shout. Oh, Stevie B. There we go.
Don't forget Carl.
Oh yeah, I said Carl.
I did.
Yeah, but don't forget him.
Yeah, but don't forget him. No, I won't forget you, Carl. David Oliver's going to go and make a sandwich. Okay, what do you like on your sandwich, David?
Bread.
No, on your sandwich, not in your sandwich.
It's always a good starting point, though.
Oh yeah, you got to start with bread.
Ham. Bit of ham.
Oh, ham. I am.
Ham. Sam, innit?
Oh, and Stingray was there earlier. I remember him.
He did
popping
make
in.
a very, very brief visit, didn't he?
Yeah, he's usually hiding in Discord, but he's not there at the moment. We're all muted over there except for me. Okay, get that out of the road. I'll say goodnight, Terry. Night, Peanuts. Night, Clyde.
Night, Terry.
Night, John.
Night,
Night,
Peanuts.
Farmers. Night, Blue.
Night, Terry. Night, Peanuts.
Good night, Peanut.